Hello students, welcome to IMS Gate Academy Gate Score Booster session on digital circuit subject. This is the second session regarding digital circuit subject. So this session is common for 4 branches: EC, electrical, instrumentation and computer science. I hope all of you attended yesterday's session as well. Whoever not attended yesterday's session, so kindly watch that session whenever you get the time. Okay, that particular lecture is already available in our YouTube channel. So just check in the playlist or in the live section regarding the live sessions in our YouTube channel at our IMS Gate Academy, right? So regarding digital circuits gate score booster session part 1, whoever missed yesterday, kindly watch that session, because in the yesterday session we have discussed 21 questions. Okay, so those 21 questions regarding the first chapter, that is number systems and codes, second chapter Boolean algebra and K-maps, and the third chapter logic gates implementation. Okay, so we have discussed from the first 3 chapters of digital circuit subject. In the yesterday session, total we have discussed 21 questions. Okay, so whoever missed that particular session, kindly watch it. Definitely it is going to help for all the aspirants of the GATE 2025 exam, whoever belong to EC, electrical, instrumentation, computer science. Yeah, very good evening one and all. Good evening Anish, good evening Mathan, very good evening one and all. Okay, similarly in this particular session also, okay, we are going to discuss 21 questions, okay, related to the remaining 4 chapters of digital circuit subject. So the 4th chapter is combination circuit, then 5th chapter is sequence circuits, and then 6th chapter data converters, and the last chapter, that is CMOS logic family. Okay, so regarding the last 4 chapters of digital circuit subject, in this particular session we are going to discuss 21 questions. Okay, right. So all of you kindly share, all of you kindly like and share this video link with all of your friends, so that they also will attend this session live and they also will get benefited from this particular session. And whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon, so that you will be getting the instant notification. Yeah, good evening Vaibhav. I hope all of you are ready for today's session. Okay, so I am showing the first question of this particular session. With respect to the last session, the continuation number is 22, because in the yesterday session we have discussed 21 questions. Now continuation we are discussing. Okay, yeah, very good evening Gopal. So all of you give a try. This is a question related to the combination circuit. Yes, very good Anish, very good. Yeah, in this particular question you are having 4-bit parallel binary adder. Okay, so that means here the circuit will perform addition of 2 numbers. Okay, here A is a 4-bit number, here another 4-bit number you are having. Okay, so in general this particular circuit will perform addition operation, but here if you observe, here A bits we have given directly, but instead of B bits directly, we are passing the respective B bits through the XNOR gates. Okay, and for all these XNOR gates, the other input we have kept 0. Okay, so for generalized case, whenever you are having 2 input XNOR gate, if one of the bit is 0, okay, other bit for the time being I am considering as B suffix I. What will be the output you are getting? All of you mention in the chart. Yes, very good Vaibhav, very good. So I am asking simple question like 0 XNOR BI. Because here all are 2 input XNOR gates, one of the input is 0, other input is any 1 bit correspond to B. Okay, 0 XNOR BI, that is nothing but 0 bar and BI bar plus 0 into BI. Just like A XNOR B is nothing but what? A bar B bar plus AB. Yes, very good Vaibhav, very good. So here 0 bar is 1, 1 into BI bar plus 0 into anything is 0. When you are adding 0 to anything, resultant answer will remain same. That means very simple. Whenever you are having 2 input XNOR gate, if one of the input is 0, the other input is getting complement at the output. That's all. Okay, that is BI bar, correct? Yeah. So here accordingly you are getting what? B3 bar. Similarly here B2 bar, then B1 bar and then B0 bar. Okay, so now just observe, A bits you are giving directly. Okay, here instead of B input, what you are getting? Each bit of B, the complement version you are giving. Okay, and then here you are adding 1. That means very simple, you are getting like A plus 1's complement of B plus 1. That is nothing but A plus 2's complement of B, that is nothing but A minus B. So that means this particular circuit is producing the output as A minus B. Okay, that is the beauty of 2's complement technique. With the help of same adder circuit, we can get, based on the requirement, you can get either addition output or subtraction output. Okay, right. So now once if you understand this logic, okay, now first of all A input I am writing as it is. Here A input we are having 1001. A input we are having 1001. Next, regarding B complement version. Here complement means 1's complement, I mean to say, with respect to this logic. So here all the bits are 1's. So 1's complement means you are getting all the bits are 0's. Then after this, here C in value you are having 1. C in value is 1. Now here just you have to perform the addition, that's all. Because here this circuit is performing addition operation, A inputs and then complement of B inputs and then C in value 1, that's all. Now just perform the addition, 1 plus 1, that is sum is 0, carry is 1. Here 1, then 0, then 1. Now this is the final answer, that's all. 1 0 1 0. Okay, yeah, very good. All of you got the same answer, 1 0 1 0. For this question, answer is 1 0 1 0. But suppose if they ask you that regarding this particular number, equivalent decimal value, if they ask, then what is the answer? A is a 4-bit number, B is a 4-bit number you are having, and then C in value 1. Now, after performing the addition operation like this, you got 4-bit number like this. For this 4-bit number, what is the decimal equivalent? Here all the numbers are represented in 2's column form. That is the wording important. So with respect to 2's column form, for this number, what is the decimal equivalent? See, it is very simple. Here you are having 4-bit number, right? So just represent the positional weights 2 power 0, 2 power 1, 2 square, 2 cube. Sign bit is 1. That means minus 8 plus 2 is nothing but minus 6. Yes, very good Anish. Minus 6, that's all. You can observe here. Here you are having 1001. That is nothing but what? Minus 8 plus 1. That is nothing but minus 7. Minus 7 after that. 4 zeros plus 1 is nothing but plus 1. Okay. So minus 7 plus 1 is nothing but minus 6, that's all. Okay. So in this way, whatever the questions we have discussed yesterday class regarding the first chapter regarding 2's complement technique, so they can give like two numbers, and they can ask that either addition operation or subtraction operation in 2's complement form, and the resultant answer they can expect in 2's complement, or they can expect the corresponding decimal equivalent. So that time it is very simple. Whenever sign bit is 0, you can consider positive number, remaining bits give the magnitude. Whenever sign bit is 1, corresponding position weight is negative, and after that wherever once you are having, you can add the respective position weights. From there you can find the corresponding decimal equivalent whenever the numbers are represented in 2's complement form. Okay, I hope it is clear for everyone regarding the 2's complement technique. Okay, so whoever not enrolled at our IMS Gate Academy and whoever targeting for Gate 25 exam, okay, the students who are preparing by themselves, or the students might have taken coaching at other institute. Okay, so whatever the questions, either yesterday class or today's session, whatever we are going to cover, so definitely all of you are getting maximum benefit, because whatever the concepts you have learned, okay, whether you are good at those concepts, especially while solving the questions without doing single silly mistake. That means the most important thing, whatever you have learned, okay, so how you can get the confidence, that is the only through test series, quality test series. Here at our IMS Gate Academy, we are providing 130 plus online tests, which includes various chapter tests and then various subject tests like basic test and then advanced test and even multi-level subject test we are having, and then we are having all the mock tests as well. Okay, all together 130 plus tests we are having. And in addition to that, whoever enrolling for test series plus program, in addition to all these online tests, you are getting 33 years previous year question booklet along with the solutions. Regarding technical, you are getting all the questions, and along with that, regarding maths and general aptitude, you are getting the questions related to EC, electrical, instrumentation, computer science, mechanical, civil, 6 branches, previous year questions along with the solutions you are getting, and all these benefits also you are getting. So whoever interested and whoever want to best utilize whatever the leftover time till before Gate 25 exam, so I am recommending all of you can fill the Google form which is provided in the description of this particular video. Okay, right. So this 20% offer is there only for limited period, so kindly grab this particular opportunity, and you can see and you can feel the kind of difference in terms of improvement and performance in terms of confidence. Okay, before you are enrolling for this program and after you have enrolled for this program, and whatever the tests, whatever the gate question booklet we are having, after practicing all this, whatever the kind of confidence you are getting, it is a fantastic. Okay, so I am recommending all the students whoever not enrolled at our IMS Gate Academy, for all the students I am recommending to enroll for this particular program. Definitely you can succeed in the coming gate exam. And whoever currently in second year or third year BTech and whoever want to write the gate exam in the upcoming years, for them you can enroll for at our IMS Gate Academy for live online program. Here we are having 800 plus hours of live online classes, and all these features you can see. Whoever interested, they can kindly contact to whatever the link provided in the description here for free counseling session. You can book it. Our counselors will discuss in detail about our live online program. Okay, right. So then now let us see the next question. One more interesting question. So all of you just read the question. The question is related to full adder. Okay, first try to understand what they have given and what you are supposed to calculate. This is a very, very interesting question. So in this question, first try to understand what the given data. You are having a full adder. It is implemented with two 2-input XOR gates, okay, and then three 2-input AND gates, and then a 3-input OR gate. Okay, in general, when you are having full adder, you are having three inputs A, B, and Cn, and you are getting two outputs like sum and then carry out. Okay, so can you recall, in order to get the sum expression you can recall, and similarly you can recall the carry out expression. Whatever the sum equation you are having and the carry out equation you are having, you can implement with respect to, in this particular question, whatever the set of logic gates they have mentioned, you are allowed to use that set of logic gates. Okay, now here in this question they have mentioned that whatever the logic gates they have used, for every logic gate you are having the delay, the respective delays they have mentioned. So that means after you have given for a particular full adder, you are giving A input, B input, and the carry input at the same time. After giving all the inputs at, say for example, 0 nanosecond, in order to get the respective sum, it is taking certain time. Similarly, in order to get the corresponding carry, it is taking some time. Okay, that delays we have to find out. Once if you get the sum delay of a full adder and carry delay of a particular full adder, after that, with the help of that information, we have to calculate the worst case delay of 8-bit binary adder, which is implemented by cascading 8 such full adders. That means this question is related 8-bit ripple carry adder, that's all. But they are asking worst case delay. Worst case delay means whether the carry propagation has to take place through all the stages or not. All of you confirm? All of you confirm? Worst case delay means whether carry propagation has to take place through all the stages or not. Yeah, good evening, Taran. Yes, regarding sum equation it is correct. Yeah, regarding carry, whatever you have mentioned AB, that is only for half adder, but here it is a full adder. Yeah, definitely worst case delay means it is very simple. In the given circuit, in whichever path it is taking more time after you have given the inputs, definitely that particular path is taking maximum amount of time after you have given the input. So that particular delay is nothing but worst case delay. That's all. Okay, right. Yes, very good, Tiwari, very good. Yeah, so I hope all of you familiar regarding sum equation. Regarding sum equation of a full adder, you are having what? A XOR B XOR Cn. A XOR B XOR Cn. Okay, so this one we can write like this: A XOR B XOR Cn. Regarding XOR operator, when you are having among three variables, if you are having XOR operator, you can perform on any two variables first and then with third variable. Okay, right. So why I have written like this? It is very simple. When you read this question, in the first line it is mentioned that a full adder is implemented with two 2-input XOR gates. Okay, so here sum equation you can get directly by using a 3-input XOR gate, but in this question you are not allowed to use directly 3-input XOR gate. Instead of that, you can use two 2-input XOR gates. Okay, right. So with the help of two 2-input XOR gates, we are getting the sum. Okay, right. And then now you can observe here A XOR B we are getting. After that output I am giving as one more input for this XOR gate, and other input is Cn. Okay, finally we are getting sum equation. Okay, regarding carry out, see, if you do the simplification regarding carry out expression of a full adder, if you are doing the simplification with the help of K-map, you will be getting the expression like this: AB plus BCn plus Cn into A. Cn into A or ACn, any order you can write, there is no problem. But if you do the simplification with respect to Boolean algebra rules and laws, okay, if you do the simplification, then you will be getting expression like AB plus A XOR B into Cn. Okay, that expression majority of the students are aware, but this equation very few students might have aware. Okay, Suppose if you are not comfortable or if you are not aware regarding the carry out expression like this, at least you can give a try whenever you get the time in this particular session in between. Okay, right. So if you are facing any issue, sir, how to get this expression, you can mention in the chart. I will discuss. There is no doubt. Okay, I will explain. Okay, so this is one more equivalent expression for carry out. Okay, right. AB plus BCN plus ACN. Now, when you look at this expression, here, in order to implement carry out, we require 3 2-input AND gates and then a 3-input OR gate. Okay, right. Just observe. I have considered 2-input AND gates 3. I have given the respective inputs AB, then BCN and then ACN. After that, the respective whatever the 3 outputs I got, we have passed it through the OR gate. Okay, you can read the question here. Regarding up to XOR gates, we have used for some, then 3 2-input AND gates and then a 3-input OR gate. So this set of AND gates and then OR gate we have used in order to get the corresponding carry output, right? Yeah. Okay. So in this way, whatever the equations you are having, based on the kind of resources or logic gates they have given in the question, accordingly we have to draw the equivalent circuit. Okay, right. In this question, they have mentioned that XOR gate delay is how much? 30 nanosecond. Okay, XOR gate delay is 30. First, let us focus with respect to XOR. 30 nanosecond. Then, AND gate delay 20 nanosecond. AND gate delay 20 nanosecond. And then OR gate delay 30 nanosecond. OR gate delay 30 nanosecond. Okay, right. Now just observe. At the first stage, you have given AB inputs at the same time, but in order to get the valid output, this gate is taking 30 nanoseconds. So that means here the output is available at 30 nanoseconds. Right. Now for this XOR gate, one input you are getting at 30 nanoseconds, but other input is available at 0 nanosecond. But here we have to consider the maximum time. That is the reason we have to wait for this one. So once again this XOR gate is taking 30 nanosecond. So 30 nanosecond plus 30 nanosecond. Together you are getting 60 nanosecond. This is the sum delay. This is the sum delay of a particular full adder. Okay, right. Next, regarding the carry delay, you can observe here from the inputs to the outputs. Okay, from the inputs to the output, you are having two stages. Okay, in the first stage, all the gates are AND gates only. So that means every AND gate output you are getting at the same time, 20 nanosecond. After that, here you are having OR gate, that is 30 nanosecond. When you add these two, you are getting 50 nanosecond. This is nothing but carry delay. Carry delay. Okay, right. So this is a sum delay of a particular full adder. This is the carry delay of a particular full adder. Now just observe among these two, which one is the larger? 60 nanosecond is the larger. So definitely while you are calculating the worst case delay, since sum delay is larger when compared to carry delay, even at the last stage or leftmost stage, okay, when you are calculating the sum delay and carry delay, obviously the sum delay will be larger when compared to carry delay. So no need to calculate both. Okay, no need to calculate both. So just you calculate the sum delay since the relation between these two according to the question. Okay, you can calculate the sum delay at nth stage. Okay, that will be greater when compared to carry delay. So the sum delay formula at nth stage is sum delay of a particular full adder plus n minus 1 times carry delay. This is the formula. Suppose if you are supposed to calculate carry delay at nth stage, the formula is simple, n times Tc, n times Tc. Now you can substitute Ts value 6 nanosecond, n value is 8 and Tc value 15 nanosecond. Do the simplification, you are getting 410 nanoseconds. Yes, very good Vaibhav, very good. Yeah, gate prep, what is your name? Just mention in the chart. Yeah, very good. You got the carry out expression correct. Yeah, Prithvish, okay, fine. You are from CS branch, huh? Yeah, I hope it is clear for everyone regarding this question. If any of you are having still confusion or doubt, you can mention in the chat, I will clarify. If it is clear, you can mention the chart clear so that we can proceed for next question. Okay, you are from instrumentation. Okay, fine. Yeah, Anjelu, if it is related to this question, you can mention the chart. If it is related to overall subject, okay, related to any other concept, you can mention later. At the end of the session, I will clarify. If you are having any query related to this question, you can mention the chart. I will clarify now only. Okay, next question, all of you give a try. This is the question related to comparator regarding the number of combinations. This question is MCQ only. Among the 4 choices, only one option will be correct. So you are having the 4-bit magnitude comparator. So here, in order to get A greater than B or A less than B, 2 choices you are having, A greater than B, 2 choices A less than B. For how many combinations it is satisfying? That is the question. So among the 4 choices, only one option will be correct. Okay, first of all, tell me, when you write the truth table, okay, A is a 4-bit number in this question. Since you are having 4-bit magnitude comparator, that means A value is a 4-bit number, B is also 4-bit number. So when you make the truth table, A is a 4-bit number like A3, A2, A1, A0, B is a 4-bit number, B3, B2, B1, B0. That means total you are getting 8 bits. That means with the help of 8 bits, how many combinations of zeros and ones we can get at max? With the help of 8 bits, how many combinations of zeros and ones possible? See, here A is a 4-bit number, B is a 4-bit number. Together you are having 8 bits. When you are having 8 bits, total number of combinations possible are 2 power 8. Yes or no? Total number of combinations possible are 2 power 8. 2 power 8 is nothing but 256. Combinations of zeros and ones. Okay, these are the total number of combinations. Yes, very good, Vaibhav, very good. Now you got total number of combinations possible. Okay, now among these 256 combinations, for how many combinations both A and B will be equal? Out of 256 combinations, for how many combinations A value, B value both are same? Any guess? You understood total number of combinations are 256, among which for how many combinations A and B are equal. In this question you don't have any choice with respect to A and B are equal, but in order to decide among these choices which one is correct, I am giving the shortcut method or easiest method. First time we want to decide for how many combinations A and B are equal. Simple. Okay, I am giving the hint, at least you can give a try. When you are having 4-bit number, how many combinations you are getting? Definitely 2 power 4, that is 16 combinations. Say for example, if you have considered here 4-bit number as 4 zeros, okay. Similarly here also you are considering 4 zeros, then only we can say A and B are equal. Similarly here 0001, here also 0001, then only we can say both A and B are equal. In that manner, whatever the combination you are considering for A, same combination if you are considering for B, then only we can say A and B are equal. So either with the help of A or with the help of B, since you are having 4 bits, so here A and B are equal for 2 power 4 combinations, that is nothing but 16 combinations. For 16 combinations, we can say A and B are equal, right? A and B are equal. Yes, very good, Manit, very good. Now, from the total combinations, okay, if you are subtracting the number of combinations for which A and B are equal, now you are getting resultant number as 240 combinations. So here we told that A and B are equal, that means these 240 combinations are nothing but related to A not equal to B. I hope it is clear. A not equal to B, right? Now, whatever the combinations you got for not equal, now that combinations consider divide with 2. 240 divided by 2, that is nothing but 120. So 120 combinations for A greater than B, 120 combinations for A less than B, that's all. 120 combinations A greater than B, 120 combinations A less than B. Okay, so now you got to know A greater than B for 120 combinations you are having in option D. So that means since this question is MCQ, only one option will be correct. For this question, option D is the correct answer. Okay, I hope it is clear for everyone. If you want to check, okay, here I have discussed for 4-bit, right? So if you want to verify regarding this particular logic, whatever I have told, okay, whether it is correct or not, or in order to remember exam point of view, just you can consider A is 1 bit, B is 1 bit. You can try for that, or A is a 2-bit number, B is a 2-bit number. Follow the same logic so that you will come to know why we have done this number with 2 division, and whatever the number you are getting, that number exactly satisfying for A greater than B, the same number for A less than B. Okay, I hope it is clear for everyone, but whoever not convinced or whoever still having some confusion, no problem at all. You can consider A and B both are 1 bit, or A and B both are 2 bit. With the help of that one, once again follow the similar procedure, you can easily understand. In this manner, try to, what I mean to say, no need to by heart any formula. Not at all required for this particular subject. Even for other subjects also, like especially when any core subject, if you are having more number of formulas or big equations, okay, of course, you should not by heart any equation or formula. Rather, if you are practicing good number of questions and if you are good at logic while solving the question, definitely those formulas, whatever you are having, definitely it will come familiar to you. Once if it is familiar to you, definitely you can recall that formula in the GATE exam. Okay, the logic is most important. So whatever the, with the help of our digital circuits GATE score booster session, for whichever questions, wherever the shortcuts possible, wherever the logical oriented, or how you have to see the question, so that if you are able to visualize that question in one particular dimension, so that you can easily solve that question in less time without using pen and paper, or even with the help of less number of steps, this particular logic is going to help you even for solving some of the questions related to general aptitude or some of the questions related to maths as well. Okay, right. Okay, next question, one more interesting question, excellent question I can say. So here you are having decoder, 3 to 8 decoder. Okay, here it is a typing mistake. So you can mention here it is a decoder, 3 to 8 decoder. Okay, so here we are having 3 to 8 decoder. and 8 outputs are there, among which 4 outputs we have passed through one OR gate. Whatever the final expression here you are having, regarding that you have to identify the correct option here among the 4 choices. All of you give a try. This is a very interesting question, excellent question. Yes, very good, Vaibhav. Excellent. Excellent. So why I mentioned for this question excellent, the reason is you can observe here, just by observing the circuit diagram, this particular circuit belongs to 4th chapter, that is combination circuit, but here you are having 4 choices. Okay, here you are having 4 choices. You can observe the choices: full subtractor, full adder. You are studying in the combination circuit, whereas XNOR gate you have studied in the previous chapter, and majority gate, 3 input majority gate. I hope whoever solved the previous year questions related to EC branch, at least EC students might have aware regarding the 3 input majority gate. Okay, right. So this question is based on logic gates and combination circuit. Okay, right. Okay, just observe here. Okay. So first of all, regarding, like say for example, when you're having 3 inputs, you'll be having what? 8 combinations. Okay, here you're having what? In option A. Okay, so before analyzing the 4 choices, see, sometimes what will happen, even though you are not comfortable in any of the choice, okay, regarding that particular equivalent expression, even if you don't know, but at least with the help of given circuit, whatever the equation you are getting, with the help of that, if when you're having MCQ, whatever the equation here you are getting, with the help of that equation, if one of the choice is matching, okay, then even though if you don't know the meaning of other choices, no issue at all, because for MCQ only one correct option will be there, right? So this question is MCQ only, correct? Which of the following is correct regarding the Boolean function? This is not MSQ. Okay, right. First of all, just observe here, you're having one decoder. Okay, you're having one decoder. Now, decoder outputs are nothing but what? Minterms. In general, normal decoder outputs are nothing but minterms. So for the time being here, okay, I'm just ignoring this one. Right. Here you are getting minterms are M3, then M5, then M6, then M7. These are the 4 minterms you are getting. Now, these 4 minterms you are passing through OR gate, right? So f of ABC is equal to sum of the minterms, or you can write sigma m form, your wish. Okay. So for the timing, I am writing sigma m form. So sigma m 3567. Sigma m 3567. Okay. Right. So you are getting 4 minterms summed together. Now we have to identify this equation is matching to which choice. That's all. Okay. Right. So regarding full subtractor, full adder, XNOR gate, okay, I will be discussing in some time. First, let us see regarding 3 input majority gate. Okay, here you are having 3 input majority gate. Whoever, like other than EC branch, okay, if you don't know what is the logic function for 3 input majority gate, no issue at all. Even sometime when you are directly getting like this, you know, typical question or different sentence framing like this, no need to get panic. It is very simple. Whenever they are giving some hint, at least you can catch that hint, and based on that you can verify. Simple. Now just tell me, when you are having majority, say for example here, whatever the 3 inputs you are having, in general we are representing those inputs in terms of zeros and ones, right? So among zeros and ones, whichever are the majority, according you are getting the corresponding output. That's all. Suppose example, in one combination, if zeros are the majority, output you are getting 0. If ones are the majority, output you are getting 1. That is the meaning of majority gate. That's all. Okay. Now here, whatever the minterms here you got, now all of you tell me, when you write these numbers in terms of corresponding binary, how many ones we are getting? Number of ones in the equivalent binary number. How many ones we are getting in each combination? In 3, how many ones we are having? 2. Yes, very good, Vaibhav, very good. Okay. Now, here in 3, we are having 2 ones, 0, 1, 1. Similarly in 5, 1, 0, 1 is nothing but 2 ones. Similarly 6, 1, 1, 0 is nothing but 2 ones, right? Okay. Next. Whereas in 7 is nothing but 111. There we are having number of ones are 3. Now that means very simple. Yes, very good. Yeah, just 1 second. Yeah, very good, Prithvish. Yeah. So whatever the, like among 3 inputs, okay. So just focus regarding number of zeros and number of ones, okay. So since here we have used the word majority, it is very simple. If at least 2 inputs are 1, if you are getting output 1, that's all. Here minterm means output should be 1, right? Minterm means output will be 1, okay. So here among 3 inputs, if at least 2 inputs are 1, here 3, 5, 6 you are having number of ones 2, whereas in 7 number of ones are 3. For those combination you are getting 1. Yes. So that means it is self-understandable. Now once if you are having sigma m, what is the equivalent pi capital M? What is the equivalent pi capital M? All of you tell me. When you are having 3 bits, correspond decimal equivalent 0 to 7 in that range other than these numbers. That means 0, 1, 2, 3 is present, then 4, 5, 6, 7 already present. Okay. For these 4 combinations, you are getting output as 0. Okay. Right. Now just for reference, here I am writing number of zeros. In 0, you are having 0 is nothing but 000, right? Number of zeros you are having 3. Whereas 1 is nothing but 001, 2 zeros we are having. 2 is nothing but 010, number of zeros are 2. Similarly 4, 100, number of zeros are 2, right? Okay. So here what is happening? If at least 2 zeros you are having, or if at least 2 inputs are zeros, that time you are getting output 0. That's all. So that means here whatever the output expression you are getting, that is equivalent for 3 input majority gate. Okay, I hope it is clear for everyone. or regarding this one, regarding this particular expression, all of you do the simplification by using K-map. By using K-map, what you will be getting this equation if you do the simplification by using K-map? You will be getting like this function or not? Like this function or not? Definitely you will be getting like this. All of you just verify. That is nothing but what? Carry out expression of your full adder. Okay. In this question, everyone knows carry out expression, sum expression. Since we already discussed carry out expression here, instead of asking in this particular question carry out expression, I have given one more way. Okay. So output of like the logic function regarding 3 input majority gate, it is exactly satisfying your carry out expression of a particular full adder. Okay, because carry out when you are getting one, say for example if you are considering half adder, the moment if both the inputs are 1, output carry output you require 1. That means when you are considering 3 inputs, definitely among those 3 inputs, okay, if at least 2 inputs are 1, definitely carry output will be 1. That's all. Okay. So if you write the expression, you will be getting, after doing simplification, AB plus BCN plus CNA. That is a simplified expression. In that simplified expression, okay, what are the logics here we told, like in order to get output 1 or in order to get output 0, you can verify later. Okay. So now I am coming back to other choices. Okay. So just for verification, 3 input XNOR gate. Okay. So before that I will talk about sum equation. Sum equation of full adder, we are very much familiar. It is an exclusive OR operation, right? So sum equation of full adder, we are having, okay, regarding option B I am writing, sum equation we are having A XOR B XOR C. A XOR B XOR C. So here you are getting XOR function, the corresponding minterm numbers will be 1, 2, 4, 7. Here it is very simple. For XOR gate, whenever you are having odd number of ones present at the input, that time you are getting output as 1. Okay, 1, 2, 4, 7. Since here you are having 3 input XNOR gate, exactly opposite. So regarding option C, you will be having like other than these combinations, 0, 1, 2 present, then 3, 5, 6. See, it is very simple. No need to by heart anything. Very simple. Whatever the 3, like when you are having 0 to 7 decimal equivalent, so for those numbers convert into binary. In whichever combination you are getting odd number of ones, that time if you are getting 1, that is XOR. In whichever combination you are having even number of ones, that time if you are getting output 1, that is for XNOR. Okay. Similarly, you can try for full subtractor equation. Here regarding full subtractor, here I have mentioned borrow expression. See, borrow when you will be getting. Say for example, if you are supposed to subtract 1 from 0, because 1 is larger, 0 is smaller, that time we have to take borrow. Okay. So say for example, let us consider the ascending order. Like first combination is 0, 0, 0. 0 minus 0, 0, 0 minus 0, 0. That means we don't require any borrow. Next combination consider, next combination like 0, 0, 1. 0 minus 0 is 0, but after that 0 minus 1 is we cannot do. Okay. That time we require borrow. So 0, 0, 1 combination, that is 1. Next combination I am considering 0, 1, 0. There we require borrow. 0 minus 1, definitely we require borrow. Next 0, 1, 1. Yes, definitely there also we require borrow. Now tell me one more combination where we require borrow. I hope all of you understood the logic, how I am able to place the minterms here regarding the borrow expression. Now with this understanding, all of you tell me one more combination you will be getting, for which combination we require borrow. See, up to 3 I have written, then 4, 1, 0, 0. Do we require borrow? Not required. 5, 1 minus 0 is 1, 1 minus 1 is 0. We don't require borrow. 6 also we don't require. 7 we require. Because 1 minus 1 is 0, 0 minus 1 we cannot do. So here we require borrow. That's all. So 1, 2, 3, 7, but here it is not matching. So in that manner we can eliminate. Here option A, option B, option C we can eliminate. Okay, so in this manner, so say for example when you are practicing the questions, say for example the moment you are getting the correct answer, majority of the students stop learning from that particular question. But at least for few questions, at least for selective questions, wherever there is a possibility, like whatever the 4 choices you're having, try to understand, okay, for each and every choice what is the corresponding equivalent, or at what context that particular equation can be the correct, etc. In that manner, like with the help of one MCQ or with the help of one question like this, it is equivalent to you are solving 4 questions, right? But if you are, the moment you are getting the correct answer, suppose if you are stopping, if you don't know, at least, even though of course for this question with respect to exam point of view I have given the first approach, okay, but learning point of view I am telling, with the help of like these questions, even though you are solving one question, but it is equivalent to you are learning 4 questions like that. Okay, right. I hope it is clear for everyone regarding each and every terminology whatever I have mentioned here, okay, and the corresponding equivalent expression as well. Okay, next question. This is a very, very interesting question. I can say it is one more excellent question regarding multiplexer. So this question is MSQ. This question is MSQ. So here you are having one Boolean function pi capital M form, and here you are having choices like in order to implement that particular function, whether 2 2/1 muxes are sufficient, or 3 2/1 muxes are required, or 2 2/1 mux and 1 NOT gate, and then 4 2/1 muxes. Like that you are having, whichever options are correct that you have to choose. So first of all, tell me, whenever you are supposed to implement, or say for example whenever you are having multiplexer, at the output whatever the function you are getting, okay, in general in which form you are getting. Like regarding the second chapter, when you have learnt regarding the Boolean function, you might be representing any output expression we can represent in 4 possible ways, like sigma m form, that is sum of minterms, and then other form is product of maxterms pi capital M, and after doing the simplification you are getting SOP, that is sum of products form, another one product of sums POS. So among these 4 forms, in which forms in general you will be getting regarding the mux output? Whenever you are having any mux, it can be 2/1 mux or 3/1 mux, sorry, it can be 2/1 mux or 4/1 mux or 8/1 mux, any mux which is having the size 2 power n by 1 mux. In general, regarding the output expression, among these four representation, in which forms in general we are representing? In general, yes, very good. Either like if you are using the standard equation and if you are substituting the corresponding like input values and the selection lines, and if you are doing the simplification, you are getting SOP, and from SOP if you want you can get the standard form, that is sigma m. In general I am talking. Okay, so in majority of the questions in the gate exam also, you will be having one particular mux, they are giving set of inputs and they will be given the selection lines. They can ask the output function either in the SOP form or sigma m form. Okay, but once in a while, okay, if they want to frame the question as tricky, that time only they will be given the question as regarding the output of mux, instead of giving sigma m or SOP, they can give pi capital M. This is the one important note point you should take care. Don't be in hurry mode, even though they have given capital M, but don't consider it is a small m. Okay, that is a one important thing. Now, for this particular, so that means now you understood that regarding the mux output you are getting like SOP form or sigma m, right? Okay, now whatever the pi capital M they have given, with the help of that, you should get the simplified function in SOP. That means if you want to get the simplified function in SOP, you should have the original function as sigma m. That's all. Okay, right. So whatever the function they have given, here number of max terms are less. That is the reason first of all you can place respective 4 max terms like 0, 1, 0 is here, then 1 is here, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10, 11. Okay, so in this way you can place the respective max terms. After that, in remaining places you can put ones. Otherwise, from this function you can convert into sigma m, but there you are getting more number of minterms, so it may take more time. That is the reason whenever you want to solve any question based on K-map, first of all just observe whenever you are having a Boolean function whether minterms are less or max terms are less. Accordingly you can place the corresponding, after that in whichever form you want, in the other than the corresponding ones you can place zeros in the remaining places, or other than zeros in the remaining place you can put ones based on the requirement. Okay, now since we want to get in SOP, that is the reason we are focusing with respect to ones, you can do the grouping, that's all. Here you can do grouping of 4 ones, you are getting A bar C, right? You are getting A bar C. Similarly here you can do grouping of 8 ones, you are getting B, and then you can do grouping of 4 ones, you are getting AC bar. Okay, for this K-map only 3 possible groupings are there with respect to adjacently placed ones. The first one is grouping of 8 ones, you are getting B. After that, grouping of 4 ones, grouping of 4 ones, AC bar plus A bar C. So that means you are getting the, regarding whatever the Boolean function they have given, regarding that the SOP you are getting B plus A bar C plus AC bar, right? Okay, now the question is, for this particular expression, how many 2/1 mux is required? Like that you are having choices. So this question is MSQ based on the like choices, whichever choices according to the context they are correct, accordingly you can choose. It is very simple. First of all, I am giving easiest approach. Actually this question related to the topic implementation of logic gates using 2/1 muxes. Okay, okay. So first of all, I hope all of you are familiar regarding the standard equation of 2/1 mux. Standard equation of 2/1 mux. Say for example, I am considering like y equal to s bar I naught plus s into I1. It is very simple. If selection line is 0, I naught is connected. If selection line is 1, I1 is connected. Correct? Okay. Now, first of all, just focus this particular term. That's all. A bar C plus AC bar. That is nothing but what? A XOR C. So whatever the expression here you are having, I am writing here. A bar C plus A C bar. So that means when you observe this equation and this equation, say for example this is 1 and this one I am labeling as 2. Just by comparison 1 and 2, you are getting selection line as A, and then I naught equal to C, I1 equal to C bar, Okay, so consider 1 2/1 mux, selection line is A, right? I naught equal to C, I1 equal to C bar, Okay. In general, for any circuit, we can give the inputs in the normal form. Yesterday also we have discussed last question, right? last 3 or 4 questions we have discussed, okay, regarding logic gates, regarding NAND gates or NOR gates. Based on the kind of inputs in which form they are available, accordingly the final answer might differ, right? Okay, so now coming to C bar, since you are having direct inputs or normal inputs, so that C we have to pass through NOT gate, so with the help of that we can get C bar. So up to here we got A exclusive or C, A exclusive or C we got, okay. So for the time being, this one I am labeling as, say for example, X for easy understanding. I hope up to now, I hope it is clear for everyone, okay. Regarding AX or C, in order to get with the help of 1 2 by 1 mux, selection is A, I not equal to C, whereas I1 equal to C bar. For C bar, we are passing C through the NOT gate. That's all. Up to here we got. Now after this, whatever this entire term you are having, okay, for the time being I am labeling as X, because I have labeled for easy understanding X, okay. Now you are having expression as what? B plus X, B plus X, okay, right. So now we are having the expression B plus X. B plus X, that is nothing but what? OR gate. B plus X is nothing but OR gate. Now once again, just observe the first equation and this equation. See, when you are having the standard equation of 2 by 1 mux, just focus with respect to selection line. In one of the term you are having complement, in one term normal, okay, right. So like that, earlier you got here A bar A, okay. Now for the time being, okay, for the time being here, okay, if you want to choose selection as B, suppose you can choose anyone, either X or B. For the time being I am choosing B. If you want to choose B as selection line, that means with respect to this term there is a matching. But what about here? Here, since you are having B as a selection line, that means with respect to this term you should have B bar, right? So what I am writing here, this one I am writing like this. Can we write like this or not? All of you confirm. All of you confirm whether this equation are equivalent or not. If you are saying yes, okay, by using which law we can write this expression as like this? All of you confirm. I want to check how many of you are strong with respect to second chapter regarding Boolean algebra and K-maps. So whether this equation are equivalent or not, you can confirm whether yes or no. If you are saying yes, by using which law we can write this function as this one? Yeah, see, still some of you are having the doubt. Okay, no issue at all. When you are having a function like this, you can apply distributive law. Yesterday also we have discussed B plus B bar is 1, so you are getting what? B plus X. Yes, very good Anish, very good, excellent. By using distributive law we can write like this. But no need to by heart how to interpret or how to write this kind of expression. Very simple, just by observing the standard equation of 2 by 1 mux, whichever variable you want to choose as selection line, just observe, and after that whether that variable normal form is there with respect to selection line or complement. If normal form is there, you can introduce complement, or if complement form is there, you can introduce normal. That's all. Okay, right. After this, just in order to compare this one, I am writing this one like this. Okay, so I am writing this one as B bar into X plus B into 1. Now you can easily compare equation 1 and 3. So here in this case, selection line is B, I not equal to X, I1 equal to 1. That's all. Okay, so here I am considering one more 2 by 1 mux. Here in this case selection is B, I not equal to X, that X is nothing but AX or C. Okay, then I1 equal to 1. That's all. So in this way, for implementing this particular function, if only normal inputs are available, that time we require 1, 2, and even for NOT gate, okay, just for reference I will write here only. So for NOT gate, you will be having what? Say for example here C bar we require. C bar means we can write it as C bar into 1 plus C into 0. Now this equation I am labeling as 4. Just compare equation 1 with 4. Here selection is C, I naught equal to 1, I1 equal 0. That means with the help of 1 2 by 1 mux, you are getting C bar. That means we require 1 plus 1, 2, 3. That means 3 2 by 1 muxes in order to implement this particular overall function. Okay. Now, when not get is there, that time 2 are sufficient. Now you can observe the choices. We require 3 2 by 1 muxes. Yes, yes, that is correct. Next, we require 2 2 by 1 muxes and 1 not get. Yes, that is also correct. The first one and last one we can ignore. Okay, those are not correct. I hope it is clear for everyone. Yeah. So for this question, 2 choices are correct, B and C. I hope all of you got to know why I mentioned this question as excellent, because for solving this question, you should have the knowledge of second chapter and then knowledge of the fourth chapter as well. Okay. In this way, if you want to get good command, whatever the questions or whatever the concepts you are having related to your branch which you are appearing for coming GATE exam. Okay. So I already mentioned earlier. Once again, I am recommending whoever not yet enrolled, okay, at our IMS GATE Academy, whoever not yet enrolled. So for them, I am recommending to enroll for this particular test series plus program. Whatever the questions currently in the previous session and in this session we are discussing regarding digital circuit subject. Similarly, even for other subjects, okay, whatever the kind of questions that we are discussing, whoever want to get deeper understanding regarding the concept and regarding the method of solving, definitely these kind of questions are going to help a lot. Okay, you will be getting like that good variety of questions and quality questions you will be having here in our online test series. Okay, so you can kindly enroll for the test series plus program. The link is already provided in the description of this particular video. Right. Now the next question, this is an easy question only. I hope all of you can answer this question correctly. All of you give it a try. Here you are having 4 by 1 mux. Regarding the output expression, whatever you are getting, that expression is matching to which choice. This question is MCQ. That means only one correct option will be there. Yes, very good, Anish, very good. So whenever you are having the mux, okay, so you can use the standard equation of the corresponding mux, and in that standard equation you can substitute regarding the selection lines and regarding the corresponding inputs. After that, based on the given question, either you can do the simplification or you can represent in the standard format. Okay, right. So for this question, like since you are having 4 by 1 mux, I hope all of you know the standard equation. See, in the previous question we have used what? Standard equation of 2 by 1 mux. In a similar way, regarding 4 by 1 mux, the standard equation you will be having here. Since 4 by 1 mux, 2 selection lines are there, like S1, S0. So just for reference, I am mentioning here output of 4 by 1 mux. Since you are having 2 selection lines, like S1 bar, S0 bar, I0. It is very simple. When you are having 0-0 combination, I0 will be connected. Okay. Next, S1 bar, S0, I1. 0-1 combination, I1 will be connected. Then 1-0 combination, S1, S0 bar, I2. And the last combination, 1-1 combination, S1, S0. That time I3 is connected to the output. That's all. Yes, very good Prithvish, very good. Okay, now here in this question, selection lines are what? B and C. Here selection lines are B and C. Now you can substitute the corresponding inputs. Here in this case, I0, I1 both are equal to A only. I0, I1 both are A only. Then I2, I3 both are same, that is A bar. A bar. Now here we can do the simplification. Just observe the common terms. First and second, if you observe, we can take B bar A as common. B bar A we can take common, then C bar plus C is 1. C bar plus C is 1. Direct step I am writing. Okay. Similarly, from these two, we can take B A bar as common. After that, C bar plus C, once again it is 1. Okay. So you are getting B bar A plus B A bar, or you can write in other way, no problem. Like AB bar plus A bar B. In any manner you can write. Because AND operator will satisfy what? Commutative law. We can interchange the order of the variables. So this one is nothing but A XOR B. So that means the output of this mux, whatever the equation you got, that represents 2 input XOR gate. That's all. Having the inputs A and B. So 2 input XOR gate with A and B as the inputs. So answer for this question is option C. Okay, in this way, with the help of mux, you can implement the logic gates. Okay. Right. Next question, very interesting one, but this question is a what? MSQ. Either one option or more than one option can be correct. So here you are having 2 4x1 muxes. So regarding the final expression, among the 4 choices, whichever options are correct, you can choose accordingly. So at least all of you mentioned just by looking at this circuit diagram, even though if you don't know among the 4 choices how many correct choices are there, but at least just by looking at this circuit, at least try to choose one correct option. Try to choose one correct option just by looking at the circuit and among the 4 choices. Just by observation you can choose one correct option. After that we can find out whether we are having any other further correct choice or not. Yes, very good Anish, very good. So here just observe, you are having 4x1 mux. You are having 4x1 mux, and here selection lines are A and B. Selection lines are A and B. And here I0, I1, I2, I3. All the inputs you are having what? In terms of zeros and ones. In terms of zeros and ones. Okay. When you are having like this, it is very simple. See, the moment for any particular mux, if you are having inputs, okay, whatever the 2 power inputs you are having, if all the inputs in terms of zeros and ones if you are having, okay, now output expression you are getting, it is very simple. Whatever the selection lines you are having, among the selection lines you are supposed to perform one logical operation. That's all. Okay, what logical operation we have to perform here? It is very simple. Since here you are having like 2 selection lines, now with respect to 2 input logic gates, when you write the truth table, okay, for which logic gate in the truth table at the output you will be getting like this column. Like in general you will be giving inputs are what? 0 0, 0 1, 1 0, 1 1, right? For those 4 combinations, according the corresponding outputs you are getting 1 0 0 1. Which logic gate it is satisfying? 1 0 0 1 as the output for which logic gate? For which 2 input logic gate? It is XNOR, XNOR, right? So that means here among the selection lines you are getting XNOR operation. That means here you are getting, since A, B are the selection lines, accordingly we can represent A XNOR B. A XNOR B. Yes, very good. A XNOR B. Now once again here, whatever the inputs here you are having, exactly same. That means once again among the selection lines, among these selection lines, once again XNOR operation, that's all. Okay. So that means f of ABC equal to, okay, I will be writing here, right. So here we are getting A XNOR B. Now once again among the selection lines you have to perform XNOR operation because inputs you are having same, right. So accordingly you are getting A XNOR B XNOR C. As of now we can directly select option A. Okay, right. Now option C you are having ABC, that is AND gate. Option D you are having AB plus C. Okay, whereas option B you are having A XOR B XOR C. Okay, now we have to verify whether this one matching to any of the remaining 3 choices or not. Okay. Say for example, for the timing I am considering different variables like X and Y. If you are having X exclusive or Y for 2 input case, X bar Y bar plus XY. This is a logical expression for XNOR gate. Now here you are having the first term, in place of X you are having A XNOR B, XNOR with another variable that is C. Okay. Now see, just you can expand as per this notation, that's all. Here you are having 2 variables, both the variables individually complement, and here both the variables normal. Like that, here the first term you are having XNOR complement, logical and second term complement, plus both the terms normal form, A XNOR B and then C, A XNOR B and C, right. Now complement of XNOR we can write as XOR, then C bar plus, here you are having XNOR, that one we can write as complement of XOR, complement of XOR. Now you can observe you are having the expression something like X1 X2 bar plus X1 bar X2, that is nothing but exclusive operation. So here the first term is A XOR B, you have to perform XOR with second term that is C. Now XOR operator satisfies associate law, this one we can write it as A XOR B XOR C. Okay, so that is there in option B. So that means for this question 2 choices are correct. Actually sometimes few people are will consider they are having one misconception that, so what are the expression here you are having, now tell me whether this expression okay, whatever the relation I am writing, whether this is correct or not, just confirm. Here you are having A XNOR B and then XNOR with C. Okay, that one here I have written as A XNOR B XNOR C. So what is the difference between left hand side expression and right hand side expression? Just for reference I am giving the hint. Here you are performing XNOR operation 2 variables and then with third variable, whereas here directly you are getting XNOR operation among the 3 variables. Yes, very good Shaikh, very good, excellent. Actually these 2 are not same. Actually these 2 like this format, what I mean to say, like let us consider 4 variables you are having, 4 variables like A XNOR B and then XNOR with, okay, just for reference I am putting in the box. Say for example, when you're having 4 variables like this, A XNOR B XNOR with C XNOR D. Okay, in this case, you can represent like this. A XNOR B XNOR C XNOR D directly. But here we cannot. Here we cannot. The reason is very simple. Whenever you are having even number of variables, okay, if you are performing XNOR operation on 2 variables and then 2 variables, after that overall, that will match with your XNOR gate directly, okay, among the even number of inputs. But whenever you are having odd number of variables, that time surprisingly you are getting, instead of XNOR, you are getting what? XOR. See, the moment you are getting XOR, okay, obviously it won't satisfy for XNOR. Or even if you are having slight confusion, it is very simple. XNOR expression, see, in general we can write whether for 2 inputs or more than that, okay. So definitely for 2 input case you can easily write either for XOR expression or XNOR, okay. Now coming to the XNOR operation, XNOR logic function, I mean to say, if you are not comfortable how to write the expression, it is very simple. First of all, you can consider the XOR operation and then you can put overall expression as complement like that. Or if you want to write from the truth table, I already given the hint point. With respect to XOR gate, output you are getting 1 whenever you are having odd number of ones. Whereas for XNOR gate, you are getting output 1 whenever you are having even number of ones. Accordingly also you can apply. Okay, for 3 inputs or more than that, you can use the generalized condition. Okay, so this is a very, very important note point. Generally, many of the students may do the silly mistake here. When you are having like this, suppose for the same question, if I have given one of the choice like this, even some students might be choosing this option also, but actually that is not correct. Like that option can be correct whenever you are having even number of variables. Okay, so this is a very, very important great learning. That is the reason I have mentioned this per day question here. Okay, actually this kind of principles or basics you might have studied in the 2nd chapter. Even like whoever not yet studied till now, at least with the help of this one, at least you can verify whether it is matching or not later. Yeah, Anish, for XOR gate there is no doubt. For XOR gate, like here we have mentioned that you are performing XOR operation 2 variables and then with 3rd variable, right? Like that, like here C XOR D you are having. For any number of variables XOR gate, ultimately you are getting, after doing the simplification, that overall expression, it will match to directly whatever the number of variables you are having with respect to that XOR. There is no doubt about it regarding XOR. Only for XNOR it is varying. The reason is very simple. Just if you want to verify one simple logic I am telling, like I am considering here like all the bits are zeros. Say for example, all the bits are zeros. 0 XNOR 0. 0 XNOR 0 you are getting 1. But after that 1 XNOR 0 is what? 1 XNOR 0 is 0. Now tell me, when you are having 3 bits 0 0 0, okay, that time you are getting 1. That time you are getting 1. So 0 0 0, that means number of ones is 0. Okay, so that time you are getting 1. Fine. Next, another combination you can consider like 0 1 0. 0 1 0 if you consider, then what will happen? Okay, 1 second. 0 0 0 when you consider, if you are performing XNOR, then okay, just for reference I will write here. Okay, I am considering 0 0 0 and then 0 0 1. Suppose if you have given directly here 0 XNOR 0 is 1 and then 1 XNOR 0 is what? 0 XNOR 0 is 1. After that 1 XNOR 0, what you are getting? 0. 1 XNOR 0 you are getting 0. Now if you want to consider XNOR, then here regarding 3 zeros, that means number of ones, how many you are having? 0. Number of ones is 0, that is even number. According to XNOR you are expecting what? Output as 1. But when you are performing XNOR operation like this, here surprisingly you are getting 0. Like this combination where it is happening? For XOR. Because here number of ones is what? Overall I am talking. Here number of ones is 0, that is an even number. For even number of ones, XOR output is 0. see, the moment when you know that XOR gate output is 1 for odd number of ones, that is self-understandable that for even number of ones you are getting 0. That is the reason, like when you are having odd number of variables, surprisingly when you are performing XOR operation on 2 variables and then with third, that time it is matching to XOR instead of XNOR directly among the variables. Okay, I hope it is clear. Similarly, if you are having any doubt regarding 4 variable for XOR, you can try. Okay, for 4 variable, 5 variable, any number of variables, when you consider odd number of variables or even number of variables, XOR gate, there is no doubt, you will be getting exactly same. Okay, only for XNOR, odd number of variables, surprisingly you are getting XOR. Okay, this is a great learning. All of you can make this note point. Okay, so till now we have discussed the variety of questions regarding combination circuits. Now we are going to discuss the variety of questions regarding sequence circuits. So all of you give a try. In this question you are having D flip-flop and then T flip-flop, and here in the question they have mentioned initially Q1 Q0 value is 1 1 before applying the first clock pulse. Okay, now the question is they are asking Q1 Q0 value after applying second clock pulse. All of you give a try. Yeah, other students also please give a try. I am just keeping the suspense whether your answer is correct or not. Yes, very good Anish, very good. Yeah, regarding BCD counter, so their BCD code we have represented for the decimal digit, right? So for the single digit, we are having 0 to 9, total 10 possible values. That means that per day counter is counting only like 0 to 9. So that means 10 possible states you are getting. Accordingly, you can call that as a BCD counter, or you can say decade counter. Decade means 10. Okay. So like that, you can have any other, like say for example, if they don't say for example whatever the counter you are having, suppose let us consider with the help of 4 bits you can get total 16 states, but at max I mean to say. Okay, but instead of like all the possible states, suppose if with the help of that counter, based on the requirement, if you are producing only some set of states, like let us consider like 8 states only or 12 states only, that time we can rename that per day counter in the general way. Like suppose with the help of given counter, if we are able to get only 8 states, that means mod 8 counter. Okay, similarly with the help of that counter, if you are getting only 12 states, that means mod 12 counter. So the word mod n, generalized case, mod n counter, there capital N stands for number of unique states that with the help of given counter which we are getting, like that. Okay, right. So whenever you are getting any question regarding sequence circuit, especially when you are having multiple flip-flops, first and foremost you have to observe whether the given circuit is synchronous or asynchronous. Okay, synchronous means each and every flip-flop present in the given circuit should have the same clock signal, right? So here the clock signal is same for all the flip-flops, that means it is a synchronous circuit. That is the first observation point. And after that, based on the given circuit, okay, whatever the corresponding flip-flop inputs you are having, okay, just observe the connections and from there you can write the corresponding expressions, okay, corresponding input expressions. So here, since you are having flip-flops, definitely those are edge sensitive devices, and here you are having bubble and then edge. That means here it is the, like, each flip-flop is responding with respect to external negative edge of the clock signal, right? So here I am mentioning regarding the clock signal negative edge. Similarly, if you don't have bubble, that is a positive edge. Accordingly, you can represent the first column in this particular tabular form. After that, with respect to first flip-flop, input is D naught, that is nothing but here Q1 bar, that means earlier Q1, okay. So for reference, I am mentioning like Q1 bar, Q1 of T whole bar, okay. Similarly, here T1 is what? Okay, if you want, you can represent Q1 bar or Q1 of T bar, your wish, right? Then T1 equal to Q naught, T1 equal to Q naught, right? So with respect to D naught, that is Q1 bar, with respect to T1, Q naught, and first flip-flop output is Q naught, second flip-flop output is Q1. Now in this question they have mentioned that before applying the first clock pulse, you are having both the flip-flop outputs are 1. Both the flip-flop outputs are 1. Okay. Now you are having initially each flip-flop output is 1. Based on that, you can determine the inputs before you are applying for the next corresponding edge of the clock signal. Okay. Here Q naught is 1. Okay, Q naught is 1. Then Q1 bar. 1 bar is what? 0. Now you are applying first time negative edge of the clock signal. Before you are applying first time negative edge, D naught, T1 both are available. Okay. So regarding D flip-flop, characteristic equation, you know, output equal to D input. Since you are having 0 here, accordingly you are getting. And for T flip-flop, if you are having T value 1, your next state will be what? Complement of earlier state. Here earlier state is 1, complement of it is 0. That's all. Okay. Now based on these outputs, now you can determine the inputs here. Q naught value is 0. Then Q1 bar, that is 0 bar is 1. Now second time negative edge we are applying. Here D input is 1, you are getting immediately after applying the corresponding edge. Here T value is 0, that means there is no change in the output state. Okay. See, the moment you got like this, here in the question they are asking after applying second clock pulse, okay, after applying second clock pulse. So the moment you are getting like this, after applying second clock pulse, 1 0, some students may choose option A, but that is not correct. Why that is not correct? Because here Q naught, Q1 you are getting 1 0, but here what they are asking? Q1, Q naught. So the order of the variables is very, very important. Since you are getting Q naught, Q1 is 1 0, now from here you can write Q1, Q naught as like this, reverse, right? That is 0 1. So that is there here in option D. So in this way, after solving the question, once again read the context in which pattern they are asking. So according to that pattern, you should choose the option accordingly. Otherwise you may get wrong negative marking, especially for MCQ question. Of course, for MSQ there is no negative marking, for NAT there is no negative marking. So at least you can be careful regarding MCQ. Either it can be 1 mark or 2 mark, even though you solve the question like completely, but before you are choosing the option, once again read the context of the question, whether according to the context of the question, whether my answer is correct or not. Just have 5 seconds patience, that's all. If you are able to cross check, that means if you are verifying or cross checking once again, then definitely wherever you can do, wherever you can choose wrong option, so in all those places definitely you can correct yourself. In that manner, you can avoid the silly mistakes, and in fact you can minimize the negative marking. Okay, right. So next question, this is an easy question. I hope all of you can answer this question correctly. So this question is MSQ. Yes, very good, Anish, very good. So here this question based on ring counter and Johnson counter with respect to number of unused states. Number of unused states. Okay. So I hope everyone knows in the ring counter, like whatever the number of bits you are having, that many flip-flops we are using, that means that many D flip-flops we are using, and the number of states also same. Okay. So here with respect to ring counter, here the number of unused states labeled as P. Number of unused states labeled as P. In general, if you are having like n bits or here 3 bits, that means total number of states that you can get in general 2 power 3. But with the help of ring counter, you are getting for 3-bit case only 3 states. Okay. That means 8 minus 3, that is 5. So this many states are unused. Okay. So regarding P equal to 5, that is there in option A. Similarly, with respect to Johnson counter, number of unused states are Q. Right. But here the number of bits given as 4. With respect to 4 bits, total number of states possible 2 power 4. But in the Johnson counter, you are getting with the help of 4 bits, the number of states you are getting 2 into 4. See, in the ring counter, whatever the number of bits you are having, that many states you are getting, whereas in Johnson counter, how many bits you are having, make it double, that many states you are getting. Okay. So 2 power 4 is nothing but 16 minus 2 4s are 8. So that means you are getting 8. 8 states are unused in the Johnson counter. So for this question, 2 choices are correct, option A and option C. Yeah, next question. All of you give it a try. So in this question, you are having JK flip-flops, and here for this question, among the 4 choices, you have to observe that which choice or which statement is incorrect. Okay. Here you are having 4 statements regarding the given circuit. Whichever statement is wrong, that will be the correct answer for this question, and this question is MCQ. So for the time being, all of you tell me. So just observe. See, whatever the hint point I have told earlier, so you can follow like that. Say for example, here whatever the flip-flops you are having, both the flip-flops are having the same clock signal, that means synchronous circuit. These kind of questions, whatever the procedure earlier we have discussed, like tabular form method, in that manner you can do it. Okay, but for this question, in fact, if you know the basics, regarding the flip-flops, okay, at least few basics, with the help of that, you can easily answer these kind of questions. Okay, so first of all, I am giving the hint point for this question. Okay, so just observe here, you are having two flip-flops, both are JK. Okay, just by observing the circuit diagram, J1 is nothing but Q0 bar. J1 is nothing but Q0 bar. J1 equal to Q0 bar, whereas K1 equal to Q0. K1 equal to Q0. Similarly, J0 equal to Q1, then K0 equal to Q1 bar. Now, just observe here. You are having JK flip-flop, here also JK flip-flop. Here JK flip-flop inputs are complement to each other. One is Q0 bar, other one Q0. Here also one is Q1, other one is Q1 bar. That means JK inputs are complement to each other. Now all of you tell me, for a JK flip-flop, if the inputs are complement to each other, then JK flip-flop will become which flip-flop? If you know this one basic principle or answer for this question, you can easily solve this question. No need to use pen and paper also. That much silly question. But only thing, while you are solving these kind of questions, very first time you may not get the way, like we have to see the question in such a way that we can easily answer. But with the help of this series of lectures, whenever you are getting like this shortcuts or how you have to visualize the circuit when you are getting in the GATE exam, okay, by following which approach you can easily solve the question in less time. Definitely these methods are going to help a lot in your coming GATE exam. Yes, very good Anish. It is a D flip-flop. If J and K inputs are complement each other, then JK flip-flop will become D flip-flop, right? So that means here, even though they have given this circuit as like with the help of two JK flip-flops, now you can modify this circuit as like this is one D flip-flop. Okay, for the timing I am labeling as D flip-flop 1. Similarly, this one as D flip-flop 0. D flip-flop 0. Okay, and here whatever the J input you are having, that one only your D input. Okay, so that means whatever the input here you are having, for in this particular circuit you are having two D flip-flops and both are having the same clock signal. Okay, output of one step we are giving as input for other, whereas for the first flip-flop we are giving the complemented version of the last flip-flop we are giving as a serial input. Now can you name this particular circuit? I have given the hint point. This is one D flip-flop, this is another D flip-flop. Output of first step we have given as input here, whereas second flip-flop complement output we have given as a serial input. Now whether this circuit is ring counter or Johnson counter, okay, I have given more hint. At least you can answer now. Yes, it is the Johnson counter. See, for ring counter, the last stage normal output we are connecting as serial input, that is the ring counter, whereas the last stage complement output we are giving as serial input, that is the Johnson counter, right? So with this understanding, okay, since how many flip-flops you are having, that many bits, simple. See, in the flip-flop you can have the normal output and complement output. Based on the requirement we might be connecting normal output or complement output as the inputs, okay, but analysis wise always we will consider for the normal outputs only. That is the reason from every flip-flop, since you are getting 1 bit and since you are having 2 flip-flops, definitely it is a 2-bit, and just by observing the circuit you identified that it is a 2-bit Johnson counter. So that means option A, what is the statement you are having, that is the correct statement only. Here in this question, we have to identify among the 4 choices in which choice you are having the incorrect statement. Okay, right. Now, you are very much familiar for 2-bit Johnson counter, and we already covered in the previous question also. In the Johnson counter, you are getting number of states how many? 2 into 2, that is 4. So this is also correct statement only, right? Okay. Now, option C we have to verify. If the initial state is 0, 0, right? After applying 143rd clock pulse, whether you are getting this state or not. If you are getting, this statement is also correct statement only. Okay. So in order to answer these kind of questions, first of all, you should decide for the given circuit what is the mod value, and we already got the mod value as 4, right? Whatever the number of clock pulse they are asking, okay. So for that number, you have to perform modular division operation with respect to, for the given circuit, what is the mod number you got. Now, 4 3s are 12, remainder is 2, then 3, 4 5s are 20, remainder is 3. That means after applying 143rd clock pulse, whatever state you are getting, the same state you are getting even after applying 3rd clock pulse. Okay, simple question I am asking. All of you tell me, whatever may the integer number you can consider, whatever may the integer number in general, when you are doing the division with 4, what are the possible remainders you are getting? Any integer number you can consider. If you are dividing with 4, what are the possible remainders? Since you are performing division with 4, you will be getting remainders are what? 0, 1, 2, 3. Very good. That means, say for example, if you are considering multiples of 4, okay, regarding the clock pulse number, I mean to say, for that multiples of 4, after performing the division, definitely you will be getting what? Remainder is 0. That means whatever the initial state you are having, even after applying multiples of 4 regarding the clock pulse number, there also you are getting same state. Like that. Suppose if you are getting remainder 1, that means after applying first clock pulse, what is the state you are having? Same. Similarly, after applying second clock pulse, after applying third clock pulse, after that what is happening? Once again remainder is 0. That's all. Okay, right. Now here, since you got remainder is 3, so you have to continue up to third clock pulse. That's all. Okay. So in this question, like first flip-flop output is Q1, second flip-flop output is Q0. Okay, right. See, in general, you might be writing the tabular form completely, but for the time being, in short, I am writing like this. Okay, because we identified this as Johnson counter, right? 2-bit Johnson counter, right? Okay, so here, clock pulse numbering, if you want, you can mention. It is a positive edge in this case given, right? So here, 3 clock pulses we have to apply. Initially, they have given 0, 0. Now, what is happening? After applying first clock pulse, this 0 is coming here because it is a direct input, okay, whereas here, this one complemented, right? 0 bar is 1. Next clock pulse, this one is coming here, 0 bar is 1. Third clock pulse, this one is coming here, complement of 1, 0. Okay, 0, 1. So here Q1, Q0 is 0, 1. Yes, exactly same. That means whatever option A, option B, option C, those statements are correct. That means option D you can observe. None of the above is true. Actually, that is a wrong statement. Actually, all these 3 statements are correct. So for this question, option D is the correct answer. Okay, I hope it is clear for everyone. Suppose the same question, if we want to frame as MSQ, so you can have the statement like this. Instead of incorrect statement, choose the correct statements. Correct statement or correct statements. In that case, option A, option B, option C. Those 3 choices are correct. Okay, I hope it is clear for everyone. Next question, very interesting question, excellent question. All of you give it a try. Well tried, Anish. Almost closer to the answer. Okay. So just cross check. You're almost nearer to the answer. So first of all, tell me here in this particular circuit, okay, whatever the D flip flop, any one D flip flop you can consider in this circuit, that particular D flip flop operating in which mode? Any D flip flop you can consider. Any D flip flop is operating in which mode? Or in other words, I will ask one simple question. Say for example, if you consider the first D flip flop, after giving the respect to negative edge of the clock signal, what will be the corresponding output with respect to earlier output? See, it is very simple. Here just observe this circuit. D input is nothing but what? Regarding the same flip flop, earlier complemented output. Yes or no? Yes, very good, Anish, very good. So it is very simple. First and foremost, you should observe that in this question, with respect to one flip flop, I am analyzing the same analysis even for other respective flip flops. Okay. So here in this case, for generalized case, I am considering like Q of t plus 1 equal to D. But in this question, the corresponding D is nothing but the same flip flop earlier complement output. So that means you are getting like this. You are getting like this. Okay. Now, when it is happening with respect to your external clock signal, whenever clock signal changes from 1 to 0, that means negative edge. Okay. Now, like this equation, you can get with respect to T flip flop by considering T value 1. I hope all of you know that one. Okay, just for reference I am mentioning Q of t plus 1 with respect to T flip flop. T XOR Q we are having. If you consider T value 1, if T equal to 1, then Q of t plus 1 equal to 1 XOR Q, that is nothing but Q bar. Okay, here once again I am considering the respect to clock signal is negative edge only. Okay, right. So actually you might have studied regarding one counter in the digital circuits subject, where you are having like let us consider 3 T flip flops are there. For every T flip flop, T value is 1 only. Okay, only for the first flip flop we have given the external clock signal, whereas for other flip flops the output of previous state we have given as the clock signal. Okay, now exactly same thing. Here in this circuit you are having D flip flops, but based on the observation, like whatever the characteristic equation after doing the simplification you are getting, that is exactly matching with respect to T flip flop when you consider T value 1. Okay, so that means it is very simple. Here this is like T flip flop 0, T flip flop 1, T flip flop 2. Okay, and here normal output we have given as a clock. For every flip flop, clock signal is negative edge triggered, but the clock signal is not same for every flip flop. See, in this question the external clock signal is not same for every flip flop. Only the clock signal, direct clock signal we have given here, whereas here clock signal is Q0, here clock signal is Q1. Okay, I hope all of you able to recall. Now for this particular circuit, this is the inherent logic. Okay, just like earlier also one question we have seen regarding Johnson counter. Similarly, for this particular circuit, once if you understand the simplified equation like this you are getting with respect to every D flip flop, right? And now you can replace these D flip flops as T flip flop, and the corresponding T values are 1. Okay, and for every flip flop we have used the negative edge triggering, and the normal output of one step we have given as the clock signal for next stage. Now can you tell this overall circuit is nothing but binary up counter or binary down counter? Which one? If you are able to recall, after that this question is nothing. We can easily solve this question. at least you identified that it is a 3-bit ripple counter. Okay, as of now we got it is a 3-bit ripple counter. That is the first observation. The given circuit is 3-bit ripple counter. Okay, and here since every flip-flop is having negative edge triggering and the normal output of one step we have given as a clock signal for next, this overall circuit actually it will work as up counter. Okay, you can refer your notes whatever you are having. Okay, you can refer later. So the given circuit actually it is the binary up counter. Binary up counter. So when you are having 3 bits, definitely it will produce 2 power 3 states. Okay, only with the help of ripple counter or binary counter we can get all the 2 power n states, whereas ring counter and Johnson counter we cannot get all the possible states. Okay, right. So here, so with respect to mod number I am mentioning 2 power 3, that is 8. Mod 8 counter. Mod 8 counter. Okay, right. Now the question is what? After applying 142 negative edges of the clock signal, right? So already we have done like this procedure earlier also. You have to perform modular division operation. Modular division operation. So here 8 and we have to analyze for after applying 142. 8 ones are 8, remainder is 6, then 2. 7 8s are 56, remainder you are getting 6. So that means after applying 142nd negative edge of the clock signal, what is the state you are having? The same state you are going to have even after applying 6th negative edge of the external clock signal. Okay, so that means here before applying the clock signal, that means initially you are having 000. Now we have to apply 1 clock pulse. Like that we have to apply 6th negative edge of the clock signal. That means now at least can you answer? Here in this circuit you are having like Q0, Q1, Q2. Okay, but here the final whatever Q2 here you are having, that is your MSB. Okay, here we have considered with respect to our unsigned convention Q2, Q1, Q0, and here once if you understand it is a up counter, you can write in the normal sequence. Okay, right. So here we have to apply 6 clock pulses. That means for first clock pulse value will increment by 1, 0 0 1, second clock pulse 2, 0 1 0, like that. 6th clock pulse you are getting 1 1 0. Anish, is it clear up to this step? Initially before applying the clock pulse you are having all the flip-flop outputs are 0, and after applying the 6th clock pulse, because for every clock pulse the counter state value is getting increment by 1, right? So like that we have to apply 6 clock pulses, that means 1 1 0. Suppose example if you got remainder is 7, then after applying 7th clock pulse 1 1 0 will become 1 1 1. That is the reason I mentioned you are almost there, nearer to the answer. Okay, right, fine. So here we are getting 1 1 0. 1 1 0 is the binary, right? 1 1 0 is the binary. So 1 1 0 is nothing but 6 in the decimal. But in this question, that whatever the binary number you got, we have to represent in base 5. Okay, so 6 we can represent in base 5. That is the question. We have to represent 6 in base 5. For that, just do the repetitive division. That's all. So 5 ones are 5, remainder is 1. 5 zeros are 0, remainder is 1. So that means you are getting 1 1. That's all. So that means here in this case p value is nothing but 1 1. Okay, I hope it is clear for everyone. I hope all of you liked this question, right? If any doubt is there, sir, how it is up counter, etc., you can just verify. But still, if you are unable to get, if you are unable to get the justification whether it is up counter, down counter, still if any of you are having any confusion or slight doubt, you can mention in the chat. I will repeat. Okay, next question. You are having 4-bit ring counter, 3-bit Johnson counter, 5-bit ripple counter. Okay, here incoming signal clock frequency this much. At point A frequency is FA, at point B frequency is FB, at point C frequency is FC, and after that you are having choices. This question is choose the incorrect statement. Okay, that means this question is MCQ, only one correct option will be there. All of you give it a try. Yeah, Anish, for this question only one correct choice will be there. This question is MCQ only. Okay, anyway, one of the choice which you have mentioned, it will be correct only. D is the correct answer for this question. Okay, so just observe in this question, you are having first block is what? Ring counter. Okay, second block is Johnson counter, third block is ripple counter. Okay, so whenever they mention the corresponding bits, okay, that means accordingly with respect to that counter, like ring counter, Johnson counter means you have used D flip-flop. Whenever ripple counter is given inside that counter, you are using T flip-flop. Okay, now whatever, when you are getting like this block diagram and when you are getting a question like this, that time whatever the counters you are having, you have to modify into the mod value. Okay, regarding that counter, you have to represent mod number. That's all. So here for ring counter, we already mentioned number of states is same as number of bits. That means this counter is nothing but mod 4 ring counter, right? Mod 4 ring counter, right? So mod 4 means incoming signal frequency divided by 4. Incoming signal frequency divided by 4. That is the frequency you are getting at the output of first counter. Okay. Similarly here for Johnson counter, number of bits are 3. So that means here you are getting mod value as 2 into 3, that is 6. Mod 6 counter, right? So whatever the frequency currently you got, that frequency you have to divide with 6. That is the frequency you are getting at output of second counter. Okay. Similarly for the ripple counter, since ripple counter is nothing but binary counter, there you are getting all the possible states. So 2 power 5, that is nothing but 32. So this is the mod 32 counter. So whatever the frequency currently you got, that one you can divide with 32. Okay, in this manner you are getting frequency at A, frequency at B, frequency at C. Okay, now after this just cross verify. FB equal to 64, yes, that is the correct one. FB equal to 64 is correct, but here we have to identify the incorrect statement, right? Okay, next, so that means this is not the correct answer, answer for this question. Okay, next, regarding option B, you can observe overall mod number they are asking, overall mod number. That means for this overall circuit. Okay, see here we got mod 4, here mod 6, here mod 32. So just you have to multiply these mod values, that's all. Okay, so regarding this one I'm telling overall mod number will be 4 into 6 into 32. Okay, when you do the simplification, okay, 4 6 are 24 into 32, so definitely you will be getting 768. Okay, since it is a correct statement, this is not the correct answer for this question, right? Okay, now you are having two more choices, FA plus FB plus FC. Now add all of them, definitely you are getting 450H. That is there in option C. That is also correct statement, but it is not the correct answer for this question, right? Okay, whereas option D, if you do the simplification, you are getting 322, but in the question you are having 320H. Okay, in the choice both are not equivalent, hence it is the correct answer for this question. Yeah, coming to mod numbers, it is very simple. See, just for easy understanding, whenever you are having the mod n number, generalized case I am talking, mod n number, when you are having whatever the incoming signal frequency you are having, that frequency divided by this number, right? So that means it is very simple. When you are having generalized case, for any mod n counter, okay, numerator you are having the frequency of the incoming signal, denominator you are having number of states. That means here, like say for example, after solving this entire thing, okay, what you got here, like with respect to incoming signal and overall output signal, if you observe, this signal got divided by 4 and once again got divided by 6, once again got divided by 32. That means in the denominator, these numbers are getting what? Multiplied. So that means whatever the number here, overall you got 768. That means this overall circuit you can replace as mod 768. So that means if incoming signal frequency is F, divide by this one, that is the frequency you are getting here, that is nothing but 2H. Simple logic. Whenever you are having multiple counters cascaded, here you can observe here, only for this particular circuit, like in this circuit, only for the first stage we are having external clock signal, okay, but with the help of this counter, whatever the frequency we are getting, that frequency or that signal we are giving as a clock for next counter, and whatever the frequency here we are getting, that signal we are giving as a clock for next. So whenever various counters cascaded, whatever the mod numbers you are having, just multiply the corresponding mod numbers. In some question they can ask, just like this one, for overall circuit what is the mod value? Simple logic, just you have to multiply the mod numbers, that's all. We don't have any mod numbers addition, okay, we will be getting only here mod numbers multiplication only. Yeah, that variety of questions you won't find in the digital circuit subject, but suppose example, like if you are coming across such kind of thing, what you can do, simple logic, like say for example, whatever the incoming signal frequency you are having, okay, and for that just convert into time period. Similarly, like, or in other words I can say, whatever the incoming signal time period you are having, from there you convert into frequency, and similarly final output, from the waveform you can observe the time period, after that you can convert into frequency, after that you can observe that particular final output output signal frequency with respect to the incoming signal frequency and all. But in general, when you have studied in the control system, there you are having like series connection, parallel connection, and then cascade, etc. But here with respect to our digital circuit point of view, we are having cascaded. Actually the main application why we are using the counters in cascaded, the reason is very simple. Say for example, for easy understanding I am telling, like you are having 1 GHz frequency, okay, example. So say for example, in the practical application, when you are having like very big digital circuit or system, definitely you will be having various modules and all. So whether each and every circuit we can operate at the same frequency in the practical, Not possible, because some circuits can produce the output at fast rate, some circuits can produce output at slower rate. So according to the requirement, accordingly we can give the corresponding clock signal frequency. Say for example, here 1 gigahertz incoming signal frequency, this one mod 1000 counter, that means output frequency you are getting 1 giga divided by 1000, that is nothing but 1 megahertz. Similarly, one more mod 1000 counter, 1 megahertz divided by 1000, that is nothing but 1 kilohertz. Similarly, 1 kilohertz frequency I am passing through one more mod 1000 counter, I am getting 1 kilo divided by 1000, that is nothing but 1 hertz. That means whichever circuits you can operate in the order of gigahertz, this frequency directly, this signal you can give. Suppose whichever circuits you can operate in the order of megahertz, accordingly you can give the corresponding signal. Whichever circuits you can operate in the order of kilohertz, you can give the corresponding signal. Whichever circuits you can operate in the order of hertz, accordingly you can give this particular signal frequency. So here the counters, like if you observe here, one operation is happening, that is the division operation. Whatever the incoming signal you are having, that is getting divided with respect to the corresponding mod number. Say for example, in the interview, you may get one question like, you have to implement one circuit where that circuit has to perform like division of two numbers. Okay, all of a sudden it seems to be like new question or new circuit, but actually once if you know this logic regarding the counter operation, say for example, if they ask you that 5 divided by 2, okay, so that means you are giving 5 hertz frequency, here you can use mod 2 counter, so that means 5 divided by 2, that is nothing but 2.5. So in some question they can ask only the block level, or in some question they can ask you to draw the circuit. That time, suppose if you are supposed to perform division operation with respect to 2, that means mod 2 counter, you can consider 2-bit ring counter. Okay, suppose if you are considering divide by 3, that means mod 3 counter, you can consider either mod 3 ring counter or mod 3 Johnson counter, like that, your wish. In that manner, whichever counter you can design, accordingly you can draw the equivalent circuit. Okay, right. Next question, I hope all of you can answer this question easily. So here also you are having incorrect statement. So why I have given all the variety of questions, because the most of the time students are able to solve the questions, but they are not having the patience in order to read the context of the question. Okay, that is the reason, because of that many of the students, even though they can get very good marks, but somehow they are not having that much patience, especially during the exam time. Because of that they are losing the marks. Not only in this subject, any subject, the context or the main keyword whatever is there, so we have to focus that one, accordingly we have to answer. And similarly, one more important note, because since I am touching that particular point, especially whenever you are having NAT type of questions where the corresponding parameter, whichever parameter they are asking you to calculate, suppose let us consider resistor. Okay, that resistance value you can get either in the order of kilo ohm or ohm or mega ohm, whatever. So according to in whichever order of units they are asking, according you should mention. Suppose example you got 1000 ohm. Okay, if they are asking in the order of ohm, 1000 is the correct answer. But if they are asking in the order of kilo ohm, 1 is the correct one. So even though 1 kilo ohm is same as 1000 ohm, but when they are asking the question in the order of kilo ohm, if you are mentioning 1000, that is wrong. Of course you won't get negative marking, but for NAT, like whatever the marks you are supposed to get, you are losing, because if you not take care about order of units, that is the most important for NAT. Especially for MCQ or MSQ, since like you might have solved in the order of ohm or in the order of kilo ohm, but anyway from the choices you are getting a clue in which order of units they are giving, accordingly you can choose. But NAT, you should, after solving the question, once again you cross check in which order of units they are asking, accordingly you can mention. Yes, very good Anish, very good. Yes, this is a direct question based on the flip-flops. We already asked one point regarding statement B, we already covered earlier. Like if J and K inputs are complement each other, then JK flip-flop will become D flip-flop. That concept we already covered. So this is the correct statement only. This is a correct statement. Similarly, SR inputs, if they are complement each other, then SR flip-flop will become D flip-flop. That is also true. And in fact, if you see the truth table of SR flip-flop and JK flip-flop, like 0-0 combination, 0-1 combination, 1-0 combination, for those three input combinations, whatever SR flip-flop output you are getting, exactly similar manner for JK flip-flop. So in that process, when you have observed, SR flip-flop will become D flip-flop when you are making S value, R value are complement to each other, like 0 1 case or 1 0 case. Exactly same even for JK flip-flop. Okay. Now coming to the T flip-flop, you are familiar. If JK inputs are tied together, then JK flip-flop will become T. Okay. But even though here it is satisfying, but here it won't satisfy regarding SR flip-flop. Why? The reason is very simple. Like regarding option D, you can observe. Okay. See, for other flip-flops also, whatever I have told directly points, if you are not aware, like these conclusion points, at least you can give a try in later, like whatever the flip-flop you are having here. Okay. So for that corresponding flip-flop, write the characteristic equation, and according to the context, you can consider corresponding inputs and do the simplification. From there, it will match whatever the resultant flip-flops here we are having according to the respective characteristic equation. Okay. But for one case I am discussing regarding option D. Here you are having SR flip-flop. With respect to option D, I am discussing SR flip-flop characteristic equation is Q of T plus 1 equal to S plus R bar Q. S plus R bar Q. This is a characteristic equation. Here what we have mentioned, S input, R input both are same. So that means I am considering like this. Okay. In place of R also you can put S only. Now what you are getting? You can apply distributive law. S plus S bar you are getting 1. So you are getting S plus Q. See, when you can say T flip-flop, if you are getting T XOR Q, but what you are getting? S plus Q. It is like logical, right? It is not matching with T flip-flop. Since it is the incorrect statement, hence it is the correct answer for this question. Since they are asking incorrect statement, so whichever choice is having incorrect statement, that will be the correct option. Okay. Yeah, next question, easy question only. I hope all of you can answer this question correctly. All of you give it a try. Yeah, Anish, okay, I am giving the hint, just give it a try. So here what is the T value? Here what is the T value for this question? Yes, very good Anish, very good. So here in this question, like just observe here, you are having one OR gate, inputs are Q and then Q bar. So you are performing logical OR. X plus X bar is what? 1. X plus X bar is 1. Okay. So it is very simple. You are having T flip-flop, T value is 1. Regarding that, we already discussed. So regarding T flip-flop, characteristic equation, when T value is 1, that time you are getting Q of T bar. Since we already discussed, I am writing the direction. Okay, right. So that means here, like you are having positive edge of the clock signal, accordingly I am representing when clock signal changes from 0 to 1. Right. Okay, so if you make the tabular form, so the first column I am mentioning clock pulse, positive edge, right, and here the corresponding Q. When there is no clock pulse applied, you can assume initial state as 0. First time positive edge I am applying, here output will change or complement, 0 become 1. Second clock pulse, 1 complement is 0. Like that, what is happening? These two states only, this per day counter is repeating. Okay. Whatever the given circuit you are having, how many unique states it is producing or repeating. So accordingly we are specifying the corresponding mod number, that's all. Mod to counter. Mod to counter, that's all. Okay, for this question, correct answer is option A. So up to here we have discussed the questions related to 4th chapter and 5th chapter. Okay, whoever from CS branch, for CS branch the syllabus is up to here. Okay, right from yesterday session until today this particular question. Okay, for CS branch with respect to digital logic or digital circuit subject, total we are having 5 chapters: number system and codes, Boolean algebra and K-maps, logic gate implementation, combination circuits, sequence circuits. I hope all the CS students, of course, in fact even other branch students, everyone, whatever the questions till now we have discussed, I hope all of you are getting the confidence and interest regarding this particular subject. Okay, definitely you people, like immediately after today's session, okay, if you are having really great exam, okay, regarding digital circuit subject, after this session is getting over, you can go and attempt. In fact, you can get the correct answers, because we are discussing variety of questions and variety of models in the yesterday session and today's session all together, right? Okay, so whatever continuation questions I am discussing, that is not part of the GATE syllabus for CS branch, okay. But if you want to attend today's session, CS branch students can continue, okay, right. Now we are discussing the questions related to the data converters. Okay, this particular chapter is common for 3 branches: EC, electrical, instrumentation. All of you give it, right? I will be giving 1 minute time. This is a question related to binary weighted resistor type DSC with respect to resistor values. So this question is MSQ, either one option or more than one option can be correct. If any CS students are there, you can mention your name in the chart. Yeah, this question is simple. So here in this question, you are having binary weighted resistor type DSC. You are having 4-bit binary weighted resistor type DSC. They have given resistor value corresponding to MSB. They have given 4 kilo ohm. They are asking that among the 4 choices, which one or which options are going to be the correct one. Okay. Yes, very good, Anish, very good. See, it is very simple. No need to by heart any formula and all. It is very simple. Here you are having 4 bits, right? So first of all, consider the 4 bits in general with respect to unsigned. I am talking. So when you are having 4 bits like this, you will be putting the position weights like this: 2 power 0, 2 power 1, 2 square, 2 cube. Right? Okay. And here, okay, since they have given the bits representation like B3, B2, B1, B0. So among all the positional weights, 2 power 0 is having least positional weight. So accordingly, here this particular bit we are calling as LSB, and this particular positional weight is having maximum weight. According to this particular bit we are calling as MSB. So up to here everyone knows, right? Okay. Now coming to the binary weighted resistor type DSC, whatever the resistors we have connected, okay, with respect to every bit, now exactly opposite, that's all. Okay, see, whatever the resistors here we got, now these resistor, like whatever the positional weights here we got, okay, those positional weights multiply with the resistor value, Now whatever the individual resistor values you are getting, now what we are doing, say for example this is the LSB, right? But here whatever this overall value you are getting, that value you are giving for MSB resistor value corresponding to MSB. Okay, so resistor value corresponding to, yeah, okay, just 1 second. Here with respect to bits you are having like this, Okay, but with respect to MSB, you are getting like 2 power 0 into R, that is R. Okay, so for the time being I am just arranging this particular representation, because this representation you will follow with respect to unsigned case B3, B2, B1, B0, but whatever here I am telling like 2 power 0 into R, that you are giving for MSB, that means for B3 you are giving like this. Okay, right. So 2 power 0 into R, that is R. Okay, right. In this question R value already they have given, MSB resistor as 4 kilo ohm. So just for reference, here you can mention this is the resistor value corresponding to MSB, that is your B3, that's all. Okay, then 2 power 1 into R, 2 power 1 into R, that you are giving for, since this is B3, next bit will be B2. 2 power 1 into R, that is 2R, so 2 into 4K, that is nothing but 8K. 8 kilo ohm. Okay, so regarding B2, 8 kilo ohm you are having in option B, so that means we can eliminate option A, right. Next, this positional weight resistor, okay, we are giving for next bit, that is B1. 2 square into R, that is 4R, R value is 4K, so you are getting 16 kilo ohm. 16 kilo ohm. Right. Okay, so that means here it is not matching, so this one we can eliminate. Okay, and the last one, this particular one is for LSB. LSB is nothing but B0. Okay, 2 power 3 into R. 2 power 3 into R, that is 8R. 8R, so 8 into 4K, that is 32K. 8 into 4K, that is 32K. Yes, that is correct answer. So for this question, 2 correct choices are there, option B and option D. Okay, so in this way, see, no need to by heart anything, very simple. With respect to unsigned case, first represent the bits positional weights, and you know that which one is LSB, which one is MSB. But whatever the positional weights you got, multiply with resistor, that particular resistor value we are considering exactly opposite. If this is LSB, this particular resistor value we are giving for MSB. If this is MSB, this particular resistor value we are giving for LSB, that's all. Okay, next question. This is a question related to ADC, analog to digital converters, regarding like counter type ADC and then successive approximation ADC. This question is MSQ, either one option or more than one option can be correct. All of you give it a try. So in this question, you can observe first of all the maximum conversion time required for 8-bit counter type ADC. So regarding that conversion time, here in this question labeled as T1. So for counter type ADC, the maximum conversion time after you have given analog input, in order to get the corresponding digital output, maximum conversion time is 2 power n minus 1, that many clock cycles. Okay, whereas for successive approximation type, successive approximation type ADC, maximum conversion time is whatever the number of bits that you are considering accordingly. So here n value is 8-bit. Okay, n times clock signal time period. Okay, assume time period of the clock signal. Time period of the clock signal here they have given as 1 nanosecond. After that, here you are having like choices T1 plus T2, T1 minus T2, and then T1 by T2, T2 by T1. Yes, very good Anish, very good. Options B and C are correct, very good. So just now we have discussed directly the corresponding formula with respect to counter type ADC 2 power n minus 1 times clock signal time period. Substitute the corresponding values, you are getting 255 nanoseconds. Okay. Next, similarly with respect to successive approximation n times clock signal, you are getting 8 nanosecond. After that, you can just observe T1 plus T2, 255 plus 8, that is 263. But here 264 is there. Okay, here we have to identify the correct options. That means option A is not correct. Next, 255 minus 8, that is 247. Yes, that is the correct one, option B. Now after that, take the ratio T1 by T2. Yes, it is matching, option C. Whereas reverse T2 by T1, actually you are getting like 0.314, but here 0.314 is there, this is not correct. So in this way, whenever you are solving the MSQ questions in the GATE exam, after reading the question, you can just decide whether you can solve that question in less time or more time. If you can solve in less time, do it at that time, but whichever questions you feel, especially for MSQ, it may take more time, you can hold those questions in the second round. Second round means like after completion of 1.5 hours during your GATE exam, you can try those questions, whichever MSQ's questions are taking more time. Because while solving MCQ question, suppose if you are solving the question in the step-by-step approach and if you are able to get the correct answer, okay, that means that is the regular approach. But even some questions you cannot solve in the regular approach, rather like you might be eliminating the wrong choices. Somehow or other, for the given MCQ, if you are able to eliminate 3 wrong choices, definitely the leftover option is correct. In that manner, you can choose MCQ question. That means while you are solving MCQ question, so the question you are solving one time only. But whereas for MSQ question, suppose if all the 4 choices are like different parameters or different relations, that means even though question looks like one, but solving wise, you are solving 4 questions. But in some questions, you can have like 2 choices, 1 parameter, 2 choice, other parameter. That time you are solving the given question in 2 times like that. So that is the reason you can decide whichever MSQ questions you can solve in less time, you can do in the at the same time. When you are looking the question, you can do immediately. But whichever questions you may feel that it may take more time for solving, definitely you can keep hold of those questions in the first 1.5 hours. But definitely you can try those questions in the second round. Okay. Right, this is the dead easy question, direct question. This question is MSQ. I hope all of you can get the correct answers for this question. This is a question regarding flash type ADC. Here we are having 5-bit, so the question is regarding the comparators. Actually for the flash type ADC, among all the ADCs, this is the fastest one. This is the fastest one. So here in the flash type ADC, we are using the comparators 2 power n minus 1. Okay, 2 power n minus 1. The number of comparators that is required, the number of comparators that is required in n-bit flash type ADC is 2 power n minus 1. That means here 5-bit flash type ADC, n value is 5. 2 power 5 is 32 minus 1. That means 31 comparators are sufficient. Okay. But if you want one more comparator also you can use. But that is optional. Okay. So that is the reason here the flash type ADC you can implement with the help of 32 comparators also, with the help of 31. But among these two, minimum means 31. Okay. But we can implement with the help of 32 comparators also. Okay. Right. So for this question, 2 choices are correct, option B and option C. Okay. Right. Up to here we have discussed regarding like up to data converters chapter. So for electrical branch, the syllabus is over up to this question. Okay, coming to whatever the questions currently we are discussing, these are the questions related to the logic family chapter, especially CMOS logic family. This chapter is common for EC and instrumentation. Okay, right. Now all of you give a try. So here we are having one CMOS circuit. Regarding the output expression, you are having the choices. Here the question is MCQ only. MCQ only. Only one correct option will be there regarding output expression. All of you give a try. This is a very interesting question. Generally, few students will do the silly mistake regarding while writing the output expression or find the output expression. I want to check whether you people are able to get the correct answer or still any of you are doing some silly mistake here. So whenever you are supposed to write the output expression regarding CMOS logic circuit, just if you focus the logic or transistor network with respect to NMOS, that's all. With the help of NMOS network, we can write the output expression. Okay, here the most important thing, like I hope all of you are familiar regarding this basic concept, like whenever transistors are contained in parallel, okay, NMOS transistors here contained in parallel, among the corresponding inputs you can perform logical OR, and whenever transistors are contained in series, say for example here overall equivalent expression you are getting one transistor, that transistor input and this transistor input, among those two you have to perform logical AND because the corresponding two transistors are contained in series. Okay, right. And here one more important note point, whenever you are considering the CMOS logic, okay, between the output and ground you are having the NMOS network or NMOS transistors, between VDD and output you are having the PMOS network or PMOS transistors. Okay, the functionality of PMOS and NMOS transistors operation wise complement each other. That is the reason the full form of CMOS logic is complementary metal oxide semiconductor. We are using both NMOS transistor and PMOS transistor. The functionality of both the transistors are complement each other. That is the reason CMOS logic. Okay, and say for example, just for easy understanding, okay, forget about this entire network. Okay, suppose example, between output and ground only you are having this one transistor. At least you can answer this simple question. If you are able to answer this question correctly, that means with the help of that understanding you can easily understand whatever I am going to discuss further. Okay, now tell me, like you are having only this transistor in this particular network, when D value is 1, that time what is the output? When D value is 1, what is the output? Or you can tell whether this NMOS transistor is on or off when you are considering D value 1. D value 1 means bit value 1, that means logic voltage you can consider like 5 volt. Yes, here you can observe gate to source voltage is what? 5 volt minus 0, that is 5 volt. It is greater than threshold voltage of the NMOS transistor. So that means NMOS transistor will be on. Okay, So when you are giving bit value 1, here NMOS transistor on, that means corresponding drain and source are shorted, output you are getting what? 0. When you are giving high as the input, you are getting 0 as the output. That means what? Input is getting what? Complement version. This is the most important conclusion point. So that is the reason while you are writing the output expression for CMOS logic, but for overall expression I am telling, when you are having overall circuit or network like this, for overall output expression whatever you are getting, there you can put complement. This is the most important point with respect to CMOS logic. Okay, many of the students generally they're forgetting for putting the complement for overall output expression. By default you are getting output expression in the complement. Okay, so here first and foremost I am representing, after observation of the given circuit, it is in the CMOS circuit, CMOS logic, so you can consider output expression in the complement version. Now after this, very simple, here these two transistors are connected in parallel. Okay, so that means among these two inputs you can perform logic-LR. Okay, now you got one single transistor here, and that transistor and this transistor both are connected in series. In series means logical AND. In series means logical AND operation. Okay, now overall you got one single NMOS transistor, and that NMOS transistor and this NMOS transistor both are connected in parallel. In parallel means you can perform logic-LR. That's all. Here input is D. So in this way, whenever NMOS transistors are connected in parallel, logic-LR, NMOS transistors are connected in series, logical AND, like that. But overall expression whatever you got, you have to put complement. But if you don't put complement, whatever expression you are getting, that also will be there in one of the choice. You can observe here, if you don't put complement, whatever expression you got, that is also there, but that is not the correct one. Okay, right. Now after this, you can apply the De Morgan's law, x plus y, x1 plus x2 whole bar. That means first term complement, second term complement. Here first term is what? A plus B into C. Okay, once again you can apply De Morgan's law here. First term complement plus second term complement. After that logical AND only. Sorry. Yeah, logical AND D bar. Here A plus B is the first term. Okay, now if you continue further, A plus B whole bar is nothing but what? A bar, B bar. Yes, that is matching here. Then C bar, here we are having, and then D bar. So that means option B is the correct answer. Okay, I hope it is clear for everyone. See, once after writing expression, in order to identify the correct choice, okay, based on whatever the De Morgan's law you have learned in the second chapter, so accordingly you can apply. Okay, and even if simplification is required, whatever the other laws that you have learned in the second chapter, you can apply. Right, with this understanding, all of you give a try for this question. This question is also similar to earlier one. Here also regarding the output expression, okay, so whatever the logic currently I have discussed, with the help of that logic represent the output expression, and after that here among the 4 choices, whichever options are correct, accordingly you can choose. This question is MSQ. Okay, I am giving 1 minute time, all of you give a try. Yes, very good Anish, very good. So just observe here, you are having PMOS transistors, here NMOS transistor. That means it is a CMOS circuit, right? So here first of all, output expression you can represent overall expression complement. Okay. After that, here you are having two NMOS transistors connected in parallel. So parallel means among the inputs you can perform logic layer A bar plus B bar. Among these two inputs you can perform logic layer. Now just apply De Morgan's law. First term complement A bar whole bar, that is A. Similarly logic line second term complement B bar whole bar, that is B. That means you are getting what? AB. Okay. Now just observe here A bar plus B bar, that is not correct. Okay, here AB, this is correct. So when you are getting AB, that is one product term, but here it is a function of two variables. When number of letters and number of variables both are matching, that is nothing but min term. So with respect to min term, AB value is 1 1. When you consider, that is nothing but 1 1 is nothing but 3. That is a min term number 3. Okay. So here you are having 3 min terms are there, but actually you are getting only 1 min term. That means you can eliminate this choice. Okay. When you are getting only 1 min term, okay, with the help of 2 bits, you can write this function as pi capital M. With the help of 2 bits, you are getting the decimal equivalent range 0 to 3. In that range, for combination 3, you are getting 1. That means remaining 3 cases, you are getting 0, 0, 1, 2. That's all. Okay. With the help of this question, once again, you are getting the recap of regarding min terms, max terms, or how to represent the Boolean function. Okay. Right. If you are having sigma m, we can write pi capital M, or if you are having pi capital M, we can write sigma m, vice versa. For this question, 2 choices are correct, option B and option D. Okay, now this is the one more interesting question. Of course, you can easily solve because you are having choices. Okay, see the previous 2 questions I have asked you to write the expression, but in this question I am not asking you to find out the corresponding output expression. Rather here this question is also MSQ, but here regarding the output you should get the 0. Regarding the output you should get the 0. So in order to get 0, whichever options are correct, whichever options are producing output 0, accordingly you can choose. Okay, I am giving 1 minute time, all of you give it a try. Yeah, since this is MSQ, either one option or more than one option can be correct. So as of now, Anish is getting one option. That one option, whatever you have mentioned, that is true. But along with that, here it may satisfy some of the other options as well. Okay. So just observe here, for answering this question, whatever the, like regarding CMOS logic in today's session, whatever the first question I have discussed before writing the expression, that logic, if you catch, you can get the correct answer for this. Whatever the correct options are there, all the correct options you can choose. Okay, it is very simple. Here requirement is output we should get 0, right? Output we should get 0. Just observe here, like say for example, earlier, okay, I already given the hint point with the help of this single transistor, right? when output, like when you are giving here input 1, that time because this transistor is on, output is coming, or you can say drain and source are shorted, so that means output is connected to 0 volt or bit value 0, right? Once again the same logic we can apply, So here in this network, like between output and ground, here 2 NMOS is there, here 2 NMOS is there, these two are connected in series, after that these two networks are connected in parallel, right? So simple logic, if these two are, say for example, here if this is 1 and this is 1, the moment if these two are 1, then this transistor is on, so that means output directly connected to where? Ground. This is one possibility. This is one set of possibility I am telling. Okay, right. Now another possibility is what? The moment if you are having C value 1, the moment you are having C value 1 and D value 1. Okay, this is one more possibility. See, the moment if you are connecting C and D both are equal to 1, that means these two transistors are on, then output is connecting to ground. Okay, now it can be both combination also. That means AB values are 1, CD values are 1. That means these two transistors are on, anyway parallel connection, ultimately output is connecting to ground, like that. 3 possibilities are there. Okay, now with the help of this logic, I am giving one more chance. All of you give a try. Among the 4 choices, which option is going to be correct? I have given all the 3 possibilities. Generalized case I talked. When you are having only this one set, okay, this second set combination, and third set I considered that combination of both, like 1 and 2. Okay, just for reference I am mentioning either 1 okay. Right, only 1 or only 2 or both 1 and 2. Yes, very good, Anish. 3 choices are correct. You can observe here CD value 1, that means this combination, this set, right? Next, AB value 1, that means this set, and the combination of both, that is 1 and 2. Yes, we are having here. So for these 3 cases, for this question, option A, option B, option C are producing output value as 0, right? Okay. Coming to option D, you can observe here AB values are 0, that means here both the transistors are off, here also CD values are 0, both the transistors are off. That time here output will be connected to VDD. Okay, simple logic. Here when you are having 0, the corresponding 2 transistors here both are on, here also on, so output line connected to VDD. Okay, VDD means output value is 1. Okay, now for the same question, I am asking the question as NAT like this. Very simple. Whatever the circuit diagram earlier we have considered, exactly same circuit. Okay, now I am asking the question that for how many combinations of zeros and ones? Okay, for this overall circuit you are having 4 inputs A, B, C, D. Okay, so when you are having 4 inputs, total you will be getting 16 combinations of zeros and ones. Among those combinations, for how many combinations you are getting output value as 0? Output Y equal 0 for how many combinations? All of you give it right. Here in this question, as per the given choices, you are having 3 combinations. But like that, total how many combinations? That is the question. For that, whatever the hint point I have told here, now you can consider all these combinations together. From there, you can answer this question. This is an excellent question. All of you give a try. Don't hesitate. This is the last question regarding our digital circuit subject. All of you give a try. Whatever the answer you may feel correct, you can mention the chart. In our class, there is no negative marking. Even in the GATE exam for NIT question, there is no negative marking. Okay. All of you give a try. I already discussed the approaches. This case or this case or this case. 3 possibilities are there. You have to consider all the possibilities so that you can answer this question. Yeah, Anish, almost closer to the answer. Okay, almost closer. If any other students are trying, you can mention the chart. So accordingly, I will be given the time, or otherwise I will be discussing. Whoever wants some more time, you can mention the chart. I will be given time. Otherwise, I will be discussing. Okay. Yeah. Since you don't want, okay, I will be discussing. Right. Yeah. See, just observe here. Whatever the logic here we told, that same logic you can apply. That's all. Here the first combination what you told, what we told here, A value, B value should be 1. Okay. So here I am writing like, okay, first of all I am considering A, B, C, D. A, B, C, D, those are the 4 variables, right? Okay. So here A value 1, B value 1. That is the first case. Okay. Now regarding CD, you will be getting 4 combinations. Okay. Now here you can consider 0, 0, 0, 1, 1, 0, 1, 1. Okay. Right. Now for those combinations, here output we are getting 0. Okay. So that means here I will write the max terms. Okay. So when you consider here 0, 0, you are getting 12, then 0, 1, 13, then 1, 0, 14, then 1, 1, 15. I hope it is clear for everyone. Generally, we have discussed what? SOP to sigma m and even POS to pi capital M also. But here we are discussing, because whatever the combination you are giving here, for the respective combination you are getting output 0. That means the respective input combination is nothing but max term. Okay. When you have considered AB 1, 1, CD value can be 0, 0, 0, 1, 1, 0, 1, 1, 4 combinations. The respective 4 combinations are nothing but 4 max terms. Okay. Right. Next. This is the first case, just for your understanding. Right. Second case, what we have told. Only CD values are 1. Only CD values are 1. Now, you are getting AB 4 combinations once again. Like 0, 0 when you consider 0, 0, 1, 1. That is nothing but 3. Next, 0, 1 and then 1, 1. That means 0, 1, 1, 1. That is M7. Okay. Then 1, 0, 1, 1. That is nothing but 11. Then 4 ones, that is 15. Okay, right. So with respect to 1, you are having 4 max terms like this. With respect to 2, 4 max terms like this. Now third case, what we told, 1 and 2. That 1 and 2 is nothing but what? M15 only. Already repeated. Okay, already repeated. Okay, so just for reference, here I am mentioning like 1 and 2. Whatever the 3 possibilities we have discussed. So with respect to here, you are getting M15. So if you are getting min terms, we will be summed together, sigma m form. But if you are getting max terms, we will multiply them. Product of max term. In this process, say for example, x into x is nothing but x. So M15 into M15 is nothing but M15. One time you can consider, that's all. Okay, now you can count how many we are getting. Here 1, 2, 3, 4, then 5, 6, 7. Okay, that's all. Here M15 is repeating. Okay, since M15 repeating, we can consider one time only. I hope it is clear. Now answer for this question is 7. Here 4 plus 3, that is 7. It seems to be that here 4, 8 plus 1, that is 9. But actually you might have studied one formula during your school standard. Like say for example, this is number of P, 4, number of Q, 4, number of P intersection Q, that is 1. So number of P union Q equal to number of P plus number of Q minus number of P intersection Q. That means 4 plus 4 is 8, 8 minus 1 is 7. Okay, but generally sometimes no, few like this silly mistake. Even students are aware of all the basic standard formulas, but still some students might be doing, no issue at all. the main agenda of this core booster session is where, like, in whichever concepts you are very much strong, in that concepts, whether you are strong enough or not, just for cross checking, and even in whichever concepts or whichever questions where in general majority of the students are doing silly mistake, those areas also you are getting the alertness. So definitely these kind of silly mistakes you can avoid in your upcoming GATE exam. Okay, and wherever possible, I already discussed the shortcut methods. Definitely you people can apply those shortcut methods. Definitely with the help of that you can get very good marks in the upcoming GATE exam, because you can attempt more number of questions in less time. Okay, right. So this is the last question for today's session, right? So yesterday's session and today's session we have discussed total 42 questions. Yes or no? Yesterday 21 questions, which includes those 21 questions regarding first 3 chapters of digital circuit subject. Similarly, in this session also we have discussed 21 questions regarding the remaining 4 chapters, like combination circuit, sequence circuits, data converters, logic families. Okay, I hope all of you got great command over this particular subject, because whatever the various models we are having with respect to our digital circuit subject, with respect to your coming GATE exam, I have discussed each and every important model in these 2 sessions together. Okay, right. So total we have discussed 42 questions in both the sessions. All of you, whoever attending the live session currently, just cross check out of 42 questions, yesterday session, today's session all together, for how many questions you got correct, you can mention in the chart. And whoever watching this particular session in the later, at least you can mention that particular number, like out of these 42 questions, yesterday session and this session all together, for out of 42 questions, for how many questions you got correct, you can mention in the comment section. Okay, so I will appreciate all the students whoever whoever mentioning like more number of questions are able to attempt correct out of 42 questions, I will appreciate in the comment section there. Okay, right. And at this point of time, I'm appreciating all the students whoever actually participated in yesterday's session and today's session, right? Because of your active participation, that is the only reason I can say that we are able to make 42 questions in the 6 hours span. Okay, it is very challenging. We cannot make that many quality questions in the less time, but we are able to make it only because of your active participation. Definitely, whoever, because of any reason, whoever might have missed, no regret at all. This lecture link will be available in our YouTube channel. At any point of time, whoever missed for attending the live session, no issue, you can watch in the recorded manner. Okay, and whatever the experience you got with the help of yesterday's session and today's session, all of you can share your valuable experience, whatever the kind of experience that you got regarding digital circuit subject with the help of these 2 sessions together. Okay, you can mention the comment section or chat section. Okay, and you can mention there regarding this particular number also I have mentioned. And in addition to that, what extra, like if you have missed these 2 sessions and you just compare after attending these 2 sessions, whatever the great improvement or in terms of your preparation or in terms of your confidence regarding this particular subject towards your GATE exam, that point also you can mention if time permits in the comment section, so that definitely whatever the kind of positive comments you people are sharing, definitely that comments even other students or your juniors may see. Definitely your comments are going to help even other students who are going to write the upcoming GATE exam. Definitely each and every student, whoever from EC, electrical, instrumentation, computer science, for all the 4 branch students, this digital circuit subject is a very, very important subject. Definitely those students also will be getting maximum benefit, just like you people, the whoever students attended live and whoever students might be watching in the recorded. Okay, right. Okay, from my side, I appreciated all the students who actually participated and whoever watching these sessions in the recorded manner and whoever able to get very good marks. Okay, or I can say more number of questions they are able to get correctly. Okay, and just in order to like whoever like attending the session in live, okay, at least I should, for them there should be one extra motivation so that they can attend whatever the upcoming sessions we are taking here. At least the active participation can go increase. That is the reason I am putting here whoever attended live sessions, yesterday's session, today's session regarding our digital circuit subject, get score booster, and based on the students whoever replied in the chat regarding for the questions, whoever mentioned the answers, I have noted the names. Whoever got correct answers for majority of the questions, accordingly I am mentioning here toppers of digital circuit subject regarding our get score booster live sessions. Hearty congratulations to all the students. I am putting the names here. Okay, why I am writing the names here? Because after this session over today, whatever the lecture notes is there, that particular lecture notes will be shared in our Telegram channel, right? So in that lecture notes, you will be having whoever actually participated, whoever the toppers are there, that names I am writing here, right? So this particular PDF will be available in the Telegram channel. Okay, right. Yeah, first one I'm mentioning Anish Reddy. Okay, here there is no discrimination in our class, just like we are having like logic low and logic high, but initially whatever may be the level in terms of your knowledge or in terms of understanding or grasping power, or in order to, I can say, in terms of attempting questions. But by the end of our last class or last minute, I can say all of you whoever attended yesterday's session and today's session, definitely everyone reached to logic high. Okay, so that is the reason no need to consider the order here. Whatever the student names I'm writing, I can say all are equally performed. Okay, right. Anish Reddy from EC branch, then Medha Kulkarni, electrical. I am writing the names based on yesterday's session and today's session, both together. Okay, actually because of some reason, like few students might have attended yesterday and today not came, and few students attended yesterday and today, but today's session less time. But I am considering whoever actually participated yesterday and today together. Prithvish from instrumentation. Other student names I am writing, but I don't know the branch. But if you are there in the currently online, you can mention in the chart so that I can write here. Taran, then Vaibhav Tiwari. One more student also was there but yesterday, but he not mentioned the name. Okay, he mentioned generic name. That is the reason I am not writing that name. Okay, but remaining all the students whoever log in like in the YouTube channel, whatever the names you have mentioned, that is your names only. But sometimes few students may put the Gmail username differently. That is the reason I am not putting that name here. Okay, but one more student also we are having, but currently yesterday also I asked in the live session, can you mention your name? But he not mentioned. That is the reason I am not mentioning that student name. Otherwise, all these 5 students, I am once again telling hearty congratulations. So please keep continue whatever the preparation, the kind of preparation that you are doing currently, keep continue with the same tempo. Definitely all of you can get very good ranks in the coming GATE exam. So as of now, I have completed the GATE score booster session with respect to digital circuit subject. But as I mentioned yesterday class, I will be coming on live even upcoming Saturday and Sunday. So as of now, timings will be like 3 to 6, but you can check like if you already subscribed our YouTube channel, definitely you can see like the updated time when the session is coming nearby. Okay, right. So on coming Saturday and Sunday, I'm going to come in the live session regarding GATE score booster regarding network theory subject, that is common for 3 branches, EC, electrical and instrumentation. Similarly, after that week, one more, like once again Saturday and Sunday, I will be coming on live for regarding GATE score booster session for communication subject. That subject is common for 2 branches, EC and instrumentation. Okay, so regarding that communication, as of now the timings will be 4 to 7, but in the like exact timings you can able to get, like when the date is coming closer, you can see the upcoming live sessions in our YouTube channel. In the YouTube channel, in the IMS Gate Academy, you can see upcoming live sessions. There, if any change is there regarding the upcoming live session, exact time you can find there. Okay, right. So that you won't miss even single video right from the starting minute to till the last minute. Okay. So whoever already joined our Telegram channel, so no issue. You people can share this valuable information update to all of your friends and juniors. As I mentioned earlier, whatever the lecture notes currently I have written here, right? This particular lecture notes, our team will share in this particular group. Okay, in that group, you can see this particular page, and if you want, you can take the, if you want, you can take the screenshot. Okay, just for your reference. Okay, right. So like this, whatever the upcoming live sessions are there, so that particular lecture schedules you will be getting here, and whatever faculties have written during the live session, that lecture notes also we are sharing here, so that it will be reference for you. And like that, you are getting all the other important updates also in this particular Telegram channel. Okay, whoever not yet joined, kindly join our Telegram channel. It is free for everyone. The link is already provided in the description of this particular video. And as I mentioned earlier, you people whoever not enrolled at our IMS Gate Academy for any of the program, for those students, especially whoever targeting for GATE 25 exam and whoever want to get very good marks, definitely at this point of time you understood that with the help of yesterday's session, today's session, whatever the 42 questions we have discussed regarding digital circuit subject, the kind of impact and the kind of confidence that you people got, it is a fantastic and marvelous, I can say, right? So like that, if you want to get in each and every subject, I'm recommending, strongly recommending, okay, not just recommending, I'm strongly recommending for all the non-enrolled students, whoever the students not yet enrolled at IMS Gate Academy, for all those students I'm recommending, so kindly share this valuable important update to all of your friends and juniors regarding Test Series Plus program. The link is provided in the description of this particular video. Those students can join, or they can enroll for this Test Series Plus program. They will be getting very good quality tests here we are having at our online portal, and along with that we are having GATE PYQ booklets also, right? So all these features you are getting. So whoever want to get very good marks, and even though we are having limited time, but you can best utilize this limited time. Okay, right. Yeah, thank you everyone. We'll meet you all in the next session regarding network theory subject, GATE score booster. Okay, thank you everyone. Yeah, thank you Anish, thank you.